So in a few seconds, you'll be all live on YouTube.
Let's check. And room number 1 should now be live, actually. And I'm gonna start in room number 2.
Right. Is that the link you gave at the bottom of the chat?
Live.
At the top of the chat? I don't think so.
Wait. Checking. So normally all the links should be there. I put it in the chat. No, top of the chat, so that's only blue button related. Yeah.
No, room number 2 is also live on YouTube now, so we're good. Excellent.
Okay. Not sure I see the video.
30 people are already on the streaming.
I have day 1, room 2.
I can post the links. Well, they're on OSCW, but on the website. The links are here too.
It's called day 2, room 1, but I don't find day 1. Very good. Eight minutes.
Hey, shall we go to the next slide?
Probably.
Let's have a look.
If you have questions about BBB, do not hesitate to ask. Actually, Konstantinos can answer.
Okay, so this slide, you can put a marker. Yeah, right. Where you actually
little one,
look at it right now. It's a Australian world map.
Gosh.
Okay.
Oh, found it. Oh, it's too big. Sorry. Delete that. Ice 4. Takes some time to locate the Hepsidon, right?
Especially it's
That's okay.
People in
Hey.
Montana, right? All right. I see.
whoops.
Yeah, Eddie.
Hello.
Cool.
So we are 22 in the chat now. Here, I mean live, and
That's the
Remember
world
then-
as seen by that's the world as seen by Hayabusa last night.
Boris, you're there, right? Okay.
Yeah.
In the southern part of France, I see.
The bottom northern part.
I am around here, anyway.
So you're telling me you're not from New Zealand?
Sorry.
No, New Zealanders should be grateful that there is even New Zealand in this map. Generally, they don't get that, so...
Yeah. Nobody in Tahiti. Not yet. Not yet. Cool. Okay, we're 21 connected. 5 minutes to go. It's just like colors all over Europe, so you won't even know where everybody's from. Where is this line?
Thibaut.
Hello,
Hear me?
everyone.
Hello, Thibaut.
Preparing all the thing, the setting. How are you?
Good.
Great.
Yeah, Boris, read you. We will tell that. Yeah.
Yeah, about the audio, yes. Maybe you
On
need
the
some.
live stream, yeah, we have. There's a live.
Yeah, not everyone at once. So many people speaking. Can't hear myself. How did you manage to get to be alone at home on the weekend?
Me?
Unless you are single, right? Then that's easy.
Yeah.
I think
Who are
that
you asking, Arthur?
people were training for 6 months of
Yeah, isolation in house somehow. Yeah.
the lockdown happened, so we can train for OSCW.
I don't find the streaming for room 1. Yeah.
Me?
I'm gonna post it here for you again.
Yes. No, no, no. No, no, she's here. She's here.
Fernando, there you are.
Hello.
Hello. Hello, Samuel.
Samuel, hello. All right, now we are 27 users online, and that's 25, I think, was the number when the robots started to drop out. So it still seems that human is superior to robots, at least when it comes to BBB connection. And wow.
Seems to be working well. Now we're on 28. The streaming, we have almost 60 people on room 1, and then yeah, just 15 people lurking on room 2.
I'm surprised about my computer because actually someone threw that computer on the trash. It was rescued. I put in some more RAM, and this thing is working very well.
Somebody put more on me. Very good.
Okay, I think we have 1 minute before we go.
Yeah.
We are already live. So we start. You can also draw here where you have traveled to. I mean,
Yeah, why
at the
not?
time when you were able to travel.
I remember that time.
Oh, it's gonna be messy pretty quick.
Yeah. That's the point, right? Oh, you can put lines. All right, we're putting lines. Nobody went to Russia so far.
I'm confused.
I don't even know where to start from. Whoops.
Ta-da! Hand over to you, Red.
Yeah, all right. Welcome, everyone. Good UTC morning, like we say. So this is the Open Source CubeSat Workshop 2020. And welcome, you're online. We would have done it on the East Coast, but this year, not only computers got viruses, everybody got it. So we're online. So in a safe place, even if, I'm super close to Freddy, as I see that. Yeah, hello, Freddy. But we're good. So I'm glad that it didn't prevent from you to participate, and we still had a lot of participants, and that's really nice. So thank you for that. We have a lot of interesting talks during those 2 days, and why we're happy with that. Just a quick reminder, because we have new people coming. So we started this workshop in 2017 with Arthur from the European Space Operations Center, and thanks to the support of the LibreSpace Foundation too. In the game of space and CubeSats, where we found that there were no community checkpoints for open source, we created it, and we hope that it's a good one, and we see the people participating, and we feel like we did a good thing. So we're happy you're here. And just a little reminder, this is open source. We try to select all the projects that are already open source for the talks. We're happy with people wanting to go open source and using the workshop as a kickstart, and would love to provide this platform for that. But the spirit is really, we want to share. We want to share knowledge. We want to see people sharing experiences, building their missions, and that's why we're here today and tomorrow. So for the next slide, we have a little thing we require you to do. We are 33 people now. You all have to turn on your microphone and just scream. If you don't know what to scream, maybe scream the name of an open source or your favorite open source project. That would be it, right? I give you a countdown. Turn on your microphone. I see that you're turning on microphones slowly. Alejandro, Anita, just leave the listen only and come back with the microphone. I give you like 1 minute for that, and then we'll try. And maybe it will crash. Then give us 2 minutes. We will restart everything. We don't know. But let's try. So and don't worry.
Hello.
Just, we're here for that.
So everyone, microphone on. Mehmet, Mary, Rohit.
Okay,
Here.
the microphone. Kartik just came in.
Microphone on.
Camera is on. It's getting crazy. All right.
Okay.
You are now unmuted.
You are not.
No, that's not a headset. Okay, then it's even
It should
better
come
for the
from here,
screaming
right?
part.
Okay, you have to scream on the countdown of 5 your favorite open source project, right? Okay. 5, 4, 3, 2, 1. Go ahead. Well, right? Everybody.
Okay. This was the test, Red. Now go for the real one.
And does it work?
Real one now. Okay. Are you ready again? You can change project if you realize, that's not my favorite. Okay. 5, 4, 3, 2, 1. Go!
SatNOGS.
My ears.
My neighbors.
Good. I'm back sitting. All right. So we'll walk through some logistics, so you know what's happening, because we have 2 rooms, and here room 1 is the main room. But I leave that aspect of logistics to Pieros from LibreSpace.
Hello, everyone. Welcome in this virtual version of our great annual workshop now. and we hope that we continue to do that. And this year it's going to be a bit different, although the logistics seem similar in terms of the way that we name the different things. So there's like virtual rooms, like the one that we are in right now. So the concept is that this is the main room, and whenever nothing else is happening, people are going to be here basically following the sessions that are happening on room number 1. And for various parts of the schedule, we're going to have like 2 rooms running in parallel. So this is the room number 1, and there is also room number 2. For both of those rooms, we have live streaming set up on YouTube and recording for both of those rooms, and we're going to be splitting up the presentations and uploading them separately so that people can watch again or catch up on presentations that they missed. Because I know for sure, for me at least, like there are some conflicts between things that I want to see on both the rooms that are happening in parallel. So recording will come in handy for those kind of situations. We also do have chat channels, not only 1 per room, but 2 of them, basically. 3 if you include also the big blue button chat right here. So there is the big blue button chat here, there is also the YouTube chat, and there is also separate rooms on Element that are specifically for each one of those 2 rooms. Type in your questions or feedback or anything you want to share or say or ask about the presentation, and we will make sure to catch up on either one of those 3 channels. There is also a third part of the big blue button setup that we have right now, which is the lounge, which is just casual hangout in between presentations. This is going to be running along the schedule for today and tomorrow, so feel free to just catch up there and share any thoughts you have on projects you're working on, or just sit and wait for the next presentation. So that's kind of like the logistics setup that we have. All the links for this you can find if you go on the Indigo website, so oscw.space, and then follow the links there. On the side you can find and click on the navigation, the name is the rooms, and then in there you'll find all the different links for the things that I just said, right? Like the big blue button setups, the live streams, and also the chats. So that would be all for the logistics. Thankfully, I don't have to say where the bathrooms are and things like that, because you're on your home and you can do it yourself. And with that, I'm going to hand it over to Arthur to get us through the structure of the schedule.
Okay, thanks. So the same here. Everything is on the website, so don't even try to read the text here. You go to the website, you find the timetable, and you have the brief view and you have the detailed view. So in the brief view, you can see basically which sessions are running, and the talks, they run in parallel. So do the demo and the discussion. So that is today. This is the welcoming part. Then we have grouped into 2 sessions. It's a bit swapped here because this is room number 1. And if you go to detailed view, then you will see what are the presentations that are running in that room. So the key point here is that we really want to stick to the time. And in that way, you can even swap between the rooms and to go to the presentation that you're interested in, because we should make sure that they start really at the time that is written there. Yeah, right. So these are the running in parallel, these 2 sessions with the talks. Then we have a short break. And then we continue with the lightning talks. Again, to see the lightning talks, you go to the detailed view, you see the talks that are being given. And then we have demo and discussion sessions afterwards. At the end of the day, we have the recap. Well, it might not be the end of the day, depending on where you are. Maybe it's just late afternoon or so. But we have a short recap, and also to see how we continue tomorrow then. But after this, there will be a virtual hangout in the lounge room. So we will open the lounge room to the public. So without access key, then everyone can go in. And I should also mention that only registered people who have the access key can really join this big blue button here and be alive. But the reason is really that we don't know how many users can be supported. So far, it looks good. So we might open more and more over the day, and maybe we can even open it to the whole public. That would be the best case. So, virtual hangout tonight for sure. That's gonna be fully open, and you bring your drink. I will bring some Glühwein, and yeah, we do some casual hangout there.
Perfect.
Yeah. I hand over to Red.
Yeah, thanks. So yeah, you can stay on the timeline slide. This was good. So remember to maybe turn off your camera during the presentation, so we know who is speaking, and the speaker only turn on your camera. Turn off your microphones also too, so we kind of optimize the bandwidth. Not everybody has a nice connection, so that would help. And during question time, of course, turn on your camera and turn on your microphones and share what you want to discuss. So room 1 will start with SatNOGS, and room 2 with the open source implementation of the ESCC POS service in Rust. So we give you, if Pieros and Arthur, you have nothing else to say, I think now we can give you the kickstart to go to those rooms, and we give you like a few minutes to get there.
So
right?
3 minutes would be enough, yeah. So
yeah.
That would be great.
Yeah.
Thanks, Red, for the intro. That was perfect.
Super cool. Super cool. Everybody, you rock. You can do it.
Cool.
I'm staying here.
So
we will start with Freddy on SatNOGS, who is actually uploading his presentation right now, right, Freddy?
Okay, I'm going to room 2. See you there.
See you, Arthur. See you, Arthur.
Happy OSCW, everyone.
Yeah.
Red, can you see Freddy's presentation?
Not yet. Wait a second. I'll take presenter, and I give you presenter, Freddy. Okay, Freddy, and for everybody, that's bottom left of the view. When you're presenter, you have a plus. You can upload there. You can upload presentation, and while you're doing that, you change screen. But for us, it doesn't change anything. We still see what we were seeing, and that's ongoing like that.
So let me know when to start.
Okay, cool. Let's wait. Let's wait the right time, right?
Yeah, 2 minutes.
Very cool. Okay, maybe we can remind room 1 and room 2 links. Room 1, you're already in there. In case you wanted to go to room 2, this is here. Room 2. Hey Tanush, yeah, it's been a while. We haven't seen you. I see your message in the chat. It's good. Jan Peter, I hope the audio is better for you now. Okay. So next, so we were going to listen to Alfredos Dam Calis, aka Freddy, aka SatNOGS, if you're looking for SatNOGS. He is the guy behind almost everything in SatNOGS. Of course, there's a huge team, but he knows all the corners of SatNOGS. So whenever you have a question, whether he can answer or he knows who can answer. So that's the good person to actually talk about the state of the union about SatNOGS. Next, after this presentation, we will have docs, and I invite Ashika to prepare for that. But your presentation is already there, so it should be all right. But hope you're here around. Okay, Freddie, the stage is yours for SatNOGS, and we're happy to listen to the State of the Union for SatNOGS. Thanks a lot, Freddie.
Thank you. So hello to everyone. I'm going to present the last updates, the annual report of the SatNOGS project. So a quick intro. Okay, here we are. So the SatNOGS project is a global network of ground stations focused on automating satellite tracking and communications. To achieve this, we use an open source stack in all levels: hardware, software, on services, and on data. We try to keep the project modular so anyone can participate with custom equipment or software. And we try to automate everything. So the SatNOGS project is separated into big groups, which each of them has many sub-projects. So the one is ground station group, and the other is the web and the services. I don't use the word cloud, but it could be like cloud services. So before I move forward to analyze updates on each of these sub-projects, I want to you to get you familiarized with a term that we used the last year. It's the artifact term. When we say artifact, we mean observation, a combination of observation data like a frame from a satellite, waterfall image or data, an audio file, or everything that can come from an observation, and the metadata that accompany this observation data, like observation parameters or metadata that describe the data themselves. So let's start with the client. Client is the one that communicates with network and gets jobs and performs them. The last year we have restricted the configuration process on the client. I forgot to say that client is the software part of the ground station. So we have restructured the configuration process. We have also tried to move to a new architecture, so there is code-based refactoring and several bug fixes. We also starting support artifacts. Artifacts, it's more like an idea of moving to something more standardized with metadata and things like that. So you will see it in many aspects of SatNOGS. So we have added support in experimental, which is experimental right now, and we are moving forward. And also we did some adjustments to GR-SatNOGS changes, which is the radio software that runs on the client. We'll talk about it later. So in the future, we need to do more changes to move to the new architecture we have in our plans, to improve the artifact support, to implement an interface that will allow us to communicate with other projects from client side, and also we are going to support transmission under the SatNOGS Homes project. The next is the radio software. I talked before. It's two projects, GR-SatNOGS and SatNOGS flow graphs. They are responsible for processing and demodulating and decoding the signals that we receive with our SDR devices. GR-SatNOGS, it's an out-of-tree GNU radio module, and in combination with flow graphs that are and flow graphs are the GNU radio part that process the different satellite transmissions. In the last year, we have here are the here are some modes that we are supporting through SatNOGS flow graphs. You can see some known of them like APRS, FSK, STV. So last year we have transitioned from GR Osmo SDR dependency to GR SWAPI that allow us to use more SDRs with more configurable way. Also, we split the flow graphs logic from the GR SatNOGS project. It was merged, but we split it into a new repository, so it's easier to write right now flow graphs for your satellite. We have improved and adding new flow graphs and also the artifact support in combination with the changes in the client. In the future, we are going to improve and add more flow graphs, improve the artifact support, and also support transmission, again, under SatNOGS project. So on the hardware part, on rotator and SatNOGS antennas, we didn't have many updates the last year, mostly maintenance and small fixes, but there were several people that has constructed antennas and SatNOGS rotator inside and outside the SatNOGS project, as everything is on GitLab, all the hardware and software sources. So in the future, we are experimenting with some new concepts in rotators and antenna builds. Stay tuned for more updates. I want to also mention the LSTM kit. It was with Volva library at the Center for Astrophysics and LibreSpace Foundation. We have created the SatNOGS, this SatNOGS ground station kit for the project Library Space Technology Network, which is a pilot project that will allow 5 public libraries to build a station with the audience of the libraries and learn more about space and satellites and how things work. And now we are going to the cloud part, the web and the services that we offer as SatNOGS project. The first one is the network. You can see here the several stations green with that are online right now, and in the orange are the stations that are in testing mode. As you can see, they are spread all around the world. We still have areas that we need more stations, but yeah, just to mention here that in places that we have stations, we need even more for several reasons we can discuss later. So the network is the service that allows to manage our stations, schedule satellite observations, and display all the store, display, and rate all the results that come from these observations. The last year, we have improved performance on different levels, back and front end. We had some bug fixes and maintenance. We have improved some UI, user interface elements. Also, we have done several architectural changes due to moving to artifacts support, and also we performed almost 2 million observations the last year. In the future, we are going to improve our API and our MPI client, which can consume our API. We are going to complete the artifact support, improve scheduling automation, improve artifact observation rating system, so we can know when a satellite is alive or not. And also, we are going to support the transmission, again, under SatNOGS comms project. Some statistics, we have 245 online stations and 134 testing stations. We have almost 5,000 observations per day and almost 25,000 demodulated frames per day. You can see also the last year stats too. On the and here is an approximation of the coverage of the network right now for the last year. On the SatNOGS DB, DB is the way the place that we store artifacts. We are going to store artifacts, and also we are storing frames of satellites that come also from external sources, and it's a crowdsourced satellite mission database, and everyone can contribute and add satellite missions. The last year we have changed the UE. It's a new user interface, more user-friendly, with more details and features. We have done some maintenance, performance improvements, and bug fixes. We have a new API endpoint for TLE sets that we can distribute, and also we have distributed through it some of our TLE sets that we have generated as community. Also, we have started with artifact support, and we have integrated metasat schema by exposing our API into a JSON-LD format that uses this metasat schema, and this helps us to excuse me. So to integrate with other projects that use this metasat schema. It's like standardized some of your terms and some of your entities that you use on your project, and allows you to communicate with other projects. In the future, we are going to introduce a satellite ID that will help us solve several problems. We are going to continue with the metasat schema integration, complete artifact support, improve our API and the API client of DB, and also standardize and improve DB service in coordination with other projects that use DB. Here are some statistics. 467 satellites, some of them are already rendered, and 985 transmitters, more than 88.5 million frames the last year, sorry, in total, and all of these from 1,276 contributors from SatNOGS network or other external sources. And we're going to decoder service, which is a service we use for describing the encoding of transmissions of each satellite through the kite.io project. And also this allows us to generate scripts that decode these transmission frames. The last year we have added new decoders, improved decoding time. Also many people from satellite teams started to integrate their missions with SatNOGS by creating decoders, and even some before satellite deployment, which was very useful when their satellite deployed and they had instantly decoded data. Also, from all the DB frames we said before, 70% of them has a decoder, has been decoded by one of our decoders. In the future, we need to create more decoders, continue to involve people and satellite teams in this process, and also improve the process design of decoders, the architecture of decoding. Here are the supported decoders right now. With the blue, you can see the last year additions. And we're moving to the SatNOGS dashboards. This is a way to display and visualize all these decoded data from the satellites transmissions we get and frames. And this is done by using Grafana dashboards. Last year, several new dashboards have been created from community or from the satellite teams. and many missions had, several missions had a dashboard even before they were deployed, so they were ready to watch their satellites as soon as it was deployed. Also, many satellite teams used these dashboards for their mission analysis. In the future, we plan to create more dashboards, involve more people on satellites, and also to experiment more with Grafana alert system, so a satellite team could get alerts when something goes wrong. Finally, I would like to to highlight some of community contributions. The last year we have generated 76 TLE sets, some for before the deployment and some after the deployment. We are working on automate this TLE generation. It needs some work, but it goes well. We have done several satellite identifications through the observations we've done. There is also an integration guide for satellite teams that will like to integrate their missions with SatNOGS. It's on the wiki, so the SatNOGS wiki. Also, many users give us feedback and offer support through issues, community forum, and chat. There are many updates on SatNOGS wiki that helps to document better the SatNOGS project. Also, many people scheduled and rated observations, and of course, many amazing station owners. And for all these things and more contributions, I would like to say a big thank you to the whole SatNOGS community. It's very important, every contribution, and we appreciate it too much. So you can join us following the wiki, the repos, the community. This is the main channels, or communicate with us with our chat. Thank you. This is
All right. Thank you, Freddy.
oh, I'm time.
You can upload. Yeah, well done. Very cool. Okay, so maybe some of you had some comments or questions. So you discovered how you can upload. That's good. So Freddy, thanks a lot for all this. While somebody can turn on the microphone and camera and ask your question, feel free to do that. I see that the map actually is bringing more stations on the south hemisphere of Earth. That's pretty cool to see this happening. Fabian, you have a question or a comment? We can't hear you, sorry.
I only switched on for the discussion group, but I don't have a question.
Okay. You're here also to answer a question. So Fabian, alias Kerel on the network, you can find him over there. He's also he knows everything about SatNOGS too. That's good. There's an upload status, exactly. So this is also the first presentation where we're getting the hangout of BBB. I see Juan Lu actually uploading. That's good. Boris, you have a question. Go ahead.
Yes, thank you, Alfredo. Is that always possible to post-process some previous downloaded frames and give them back to a team if we are not the team in charge of the satellite? I mean, from the database, can we contribute to process the data and give the result back to the teams?
Yes. The data are saved. All the frames and the data are saved in database, and anyone can access them through the API and a simple API key. So even missions that are not integrated with SatNOGS, they can come and get their data after the mission.
Good to know. So it's pretty much open data. At some point, you just get a key in it. Good. There's another question from Damien. I can ask it, Damien, if you're not turning on your microphone. When should the transmission feature be live? That's a question from Damien.
Yeah, I don't have an answer for this, but we need first to do several architectural changes in the client and all the parts, the SatNOGS project, the network. We are getting there. I hope in the next months to be able to use the transmission, but I don't have a clear timeline right now.
So you have to keep yourself updated, and that's it. So feel free to join the SatNOGS channel on Matrix, and join Alfredo's Freddy, Karel, and everybody's discussions over there, and you'll know that in the time when it's actually live. Thanks a lot, Freddy. We're going to hand over to the next speaker, who is Rashika Jain. She should be presenting with Thibaut Delrio. I hope is in the chat and in the channel today. They both work with Boris Segret at the Observatoire de Paris on the DOCS project. So while Mantos is preparing your presentation right now, you can start turning on your camera, Rashika, and we can start to see you. So Rashika is a young space system engineer. She graduated last year, and she's now working on open source projects, which is DOCS. And she's keen on space mechanics, mission analysis, and she's working together with Thibaut Delrio on growing this software suite, which is actually filling a gap on mission profiles and mission analysis, if I'm correct. So Ashika, the screen is yours, and go ahead. Yeah, thank you.
Thank you. So, as Red already introduced me, I am Rashika, and I have Thibaut along with me. We are from CESRES, which is a space pole of the PSL University, hosted at the Paris Observatory. Today, we are going to talk about our in-house software, DOCS, which is being developed to design space mission profiles. Now, new space is growing every day, and there are CubeSAT projects that ranging from low Earth orbits to interplanetary missions these days, and the high costs are incurred behind these projects. So to minimize the risks, we need some mission profile tools to do the preliminary analysis. Now, there are some tools that already exist, but not all of them can do the complete mission profile, or some are very costly. So we are developing DOCS mainly to overcome this gap. DOCS does the complete mission profile, and it helps structure your CubeSAT project so that you can focus on the scientific coverage. So what is DOCS? DOCS stands for Design and Operation Cross-Checking Services. It's an open source software which targets scientific nanosatellite mission profiles. It's completely free, and it's available on the public GitLab. You can find the link here. It's fully developed and validated in Python. For now, it's only supported with Ubuntu and Windows operating system, but we will be expanding to macOS in the future. DOCS has a modular architecture, as you can see here. It has 7 different modules, which are added as plugins, but they can also be used as standalones. So each of this module has its own configuration file, which the user can set up to set up the simulation, and then the simulation can be run either in command line or via the graphical user interface. An additional advantage of DOCS is that it's compatible with VTS, which is a software developed by the French Space Agency to animate and visualize satellites in 3D environment. Here is an example of VTS, how it looks. So moving on to the different modules. The first part of DOCS is trajectory generation. So we have 2 different modules for that. Konix is one of them. It's basically a Keplerian engine, and it links to Kness Stella in the Earth vicinity. The propagator is, however, it covers a broad aspect, and it is capable of doing deep space trajectories for cruise, rendezvous, or proximity operations. The purpose of propagator is to produce an expected trajectory from a set of initial conditions, and and with the perturbations that are given in the space environment. For now, the propagator the user can enter both gravitational and non-gravitational perturbations, and for proximity operations, since the complex shape of bodies is a significant factor in trajectory, so the user can also add their spherical harmonics model or any other custom complex model. For non-gravitational models, we have continuous propulsion and the solar radiation pressure for now, but we will be adding atmospheric drag in the future. For numerical integration, we use Runge-Kutta of order 4 or Runge-Kutta-Feldberg method. The advantage of the Runge-Kutta-Feldberg is that it has an adaptive time step, but this also makes it computationally expensive. So we are looking for new methods that are not that expensive and also are accuracy driven with an adaptive time step. The propagator allows you to propagate either forward or backwards in time. The validation of this module has been done extensively, taking planets and asteroids as test cases. It means that we propagate a planet-like body in a similar space environment, and then we compare the generated trajectory with the actual FM reads. There are still some issues if very high precision and accuracy are required for a mission, but overall it works very good. Talking about the latest developments in the propagator, the continuous propulsion feature was recently added. Now it helps the user to add trajectory correction maneuvers. An initial validation has been done, and here you can see a Hohmann transfer as done by the continuous propulsion. An advanced validation is ongoing where we compare it with trajectory of an actual mission. So here you can see a graphical user interface of the propagator. We have some predefined gravitational perturbations, but apart from them, the user can also add their own custom bodies. This interface has been recently improved and is now user-friendly. For the future, apart from the changes I mentioned earlier, we are also thinking of adding a time step manager, since all the models in propagator do not require the same time step. So moving on to the next module, intervisibilities. It computes the intervisibility with the sun, means the eclipses, and the ground station passes for a specific trajectory. The output is an event file, which you can see here. So basically, it tells you the time at which you are entering an eclipse. ECL in means that you're entering, ECL egg means that you're exiting. Similarly, for the ground station, come in means that you are entering the ground station, and come egg means you are exiting the visibility. So next is the energy path simulator. It takes into account the configuration of solar arrays, cells and battery, mode strategies, pointing strategy, and the intervisibilities, and then it produces a power budget for the complete mission. For now, there is no graphical user interface for EPS, but it will be released in the future updates. So the modules I talked about till now are operational, and but the other modules have not been developed yet. But the purpose of data link is to compute the data volume on board. Quaternions and ADCS will be producing the quaternions and orientations for the satellite. So now where is DOCS used? So CESRES provides NBSC support to CubeSAT teams to design a mission profile based on the scientific requirements, and to have a complete analysis in terms of power budget, the data volume budget for the mission. So DOCS is used in these contexts by internal as well as external teams. Birdie is an internal project which uses DOCS propagator to compute trajectories for flyby around asteroids. Circus and Kester, they use docs, EPS, and intervisibilities. Here is an example architecture of for Kester that I'm working on. So the Castor team gives us some science requirements. Then I develop a mission profile. In terms of a mode strategy, a pointing strategy, and then computing the data volume and the power budget. So here we use for intervisibilities and EPS. The output is then generated in VTS. Here is an example of the outputs. So, for example, you can see flags here, which is red, which means it's a flag for energy. So it means that there is not enough power on board for the mission. So we add such flags so that you can visualize the state of your mission at that point. A similar architecture is adopted by TUDSAT in Germany and SatNOGS in Taiwan. So now I will request Thibaut to move on to the current development plan of docs.
Thibaut, we can't hear you very well at all. I hope I'm the only one. I don't know if you got me. Can somebody in the chat say if you can hear Thibaut? No sound.
No sound.
Cool. 1, 2. Yeah. Oh, it's kind of working now.
Yeah.
Go. Yeah, we can hear you.
Okay, nice. So yeah, also docs was doing the job. It was quite slow. So one of the main goals was to make it faster. In order to do that, we have implemented some new features. First of all, we wrote some parts of the code because the structure was inadequate. Some roots are not necessary.
Sorry, Thibaut, we can't hear you very well. The sound is not too good. Yeah, there is like a false contact or something. It's like you're on the ISS at the moment.
I don't know how to
or maybe an abandoned station. That's a confinement effect. Yeah. This is too noisy. Sorry. Ashika, maybe you can take over while Thibaut is.
I continue.
Maybe I can turn off my camera. Maybe it will be better.
Better, but I think it's really your connection, your connector, which is like causing problem. Every time you're moving the device, it's making a noise. So.
Okay, so I will try to not move it.
Don't move now.
Okay,
perfect.
Okay, I don't move. So secondly, we introduced parallelization into docs, which allows several tasks to be treated at the same times. And my phone is gone. And last thing, we are developing a remote service clients to run docs to our server at Paris Observatory. There are two main benefits. First, since the power of the PC turns faster, and second, it's portable at installing the software any installation at all with
sorry,
at all with this remote service.
Kind of repeating. Yeah, there's a repeating loop now.
I think I will continue.
Yeah. Go on.
So currently we are working. We are trying to make docs faster. So we have adopted since many users have worked on this, so it's very slow. So we are trying to make it faster by using techniques like parallelization and vectorizing. Basically, there are some unnecessary for loops and else if statements that we are removing from docs so that it's faster. As a result, Thibaut observed 10 times faster speed in intervisibility, for example. And then we also changed our configuration files. Earlier, it was very specific. We could not change the location of things. But now we have adopted a YML approach, and it is very user-friendly. Also, in the future, we are will try to make docs installation very easier. We are thinking to do something like as we install a Python library, simply pip install something like that. So we want to move it to that. And since a docs installation can be heavy on some machines, especially on Windows, so we are working on a remote service. We have a Cestrus server which can compute heavy computations. The idea will be that the user will just drop a configuration file and the server will compute. So in this scenario, there will be no installation required on the user side. So these are the recent developments. And so you can also contribute in docs. You can, as users, you can report bugs or boring uses, or you can request some new features. And if you're a scientist or engineer, be free to challenge our performances or add some new models. And IT enthusiasts can also help us make the user GUI friendly. Okay, so that's it. So please feel free to contribute to docs. Thank you everyone for your attention, and you can join us on these links.
Great, thank you, Ashika. This is amazing. Nice. I think you already had a question in Matrix on the Rooms channel. Actually, Juan is asking where is conic, ADCS, and quaternions. That's very advanced questions, I think. Great projects. Congratulations. Also, Damian is saying that. We're happy to see that you're getting more users. And how is the onboarding of users actually? How do you manage that? Do they usually install by themselves and you don't know what they're doing, or they reach out and?
No, we are constantly in touch with our users. We help them install, and if they are facing any problems, so we know generally what they are doing with docs.
Yeah, very nice. Nice.
Okay, about the question, conics, ADCS, and quaternions are not operational. They have not been developed yet, and conics is not operational. We use it sometimes internally, but propagator has a wider use, so it has not been released on public GitLab. Only propagator is available.
All right. Any other questions or comments from anyone?
I see one question.
Yeah, one. Sorry, if it can be my turn. Okay. Yeah. Well, great project. One question about MBSE. So I saw you're integrating model-based system engineering. So it means that you are integrated within docs. You are integrating an let's say a framework to use MBSE within docs. That's what you're doing.
It's like we have an MBSE framework and we integrate docs in that, not the vice versa. So the MBSE architecture I showed here, this is the MBSE architecture we use generally for projects, and we just use docs in some parts of this MBSE. For example, for this project, we are using it for to compute the intervisibilities with the sun and the ground stations, and for computing the power budget. For Birdie, we are using just the propagator to compute the trajectories. So it's different for each project, and it's very specific.
And have you developed any link to Capella, or you're not using Capella?
No. We have not developed any link to Capella yet, but we are looking for it right now, but something is not ready till now.
Maybe you can remind what Capella is quickly.
Capella is it's basically a tool that helps to develop MBSE architecture.
All right.
But we have not.
That's enough to understand. Very cool. Well, thanks a lot. You can reach out to Ashika. She's here. And thanks a lot, Ashika. Thanks a lot, Thibaut. I'm very sorry about the microphone issue. That's confinement life somehow. Wonderful projects. I'm really enjoying seeing that moving on. You get more users. That's really cool. And the team is growing. Well done also, Boris, on that. So next talk. Thank you, Ashika. Next talk is the open source models in satellite communications presented by LF Terios, right? Yeah, right. So LF is the vice chairman of the LibreSpace Foundation. He's present everywhere in the community. Every time I travel, even to Shanghai, people knows him. That's kind of a crazy person. So he's overseeing projects and giving a helping hand to everybody, wearing to everybody, and his talk is about one of those projects in the LibreSpace Foundation, the OpenSatCom, which is done together with the European Space Agency. So LF, the screen is yours.
Hey guys, I'll need a sec for that.
Are you presenter?
Am I presenter?
Not yet. Let me just make you presenter, and you are presenter. Perfect.
There you go. Okay. Today I'm gonna talk about OpenSatCom, which is actually an initiative, an activity of the European Space Agency, implemented by LibreSpace Foundation and our friends at France in A-Cube. The activity project focuses on evaluating open source modules, open source development modules in satellite communication. It identifies open source projects related to that mission, and also coordinates sub-activities to increase the impact of open source in satellite communications. We'll check about that in a few minutes. So the idea is that first thing is for the person is to understand first and foremost what are open source modules, because they are not just the good old open source development methodologies that you ideate the open source solution and you develop it and then you market it and then maintain it, etc., etc. But you have to take into account licensing considerations, legal considerations, your revenue model, and the community aspect. By choosing a license, your model will be impacted, either community-wise or technology-wise, maybe sometimes, and especially revenue-wise. So you have to also take into account that although open standards are key towards an open ecosystem, it should be coupled with open licenses and governance in order to have the extreme effect of open source. Nowadays, we all know that open source is the basis of many technological stacks. You can on the notes of this presentation actually have a link to a study we performed during this activity in order to define what kind of technological stacks are affected by open source today. An open ecosystem not only promotes standardization, which is normal if you think about it, but also promotes open implementation, so makes it easier for a new company, organization, a team, a university to get into the industry. We know that nowadays open source business models and models of generating revenue, being sustainable, are evolving continuously. And there are great debates about how they should go forward and how they shouldn't. We can discuss them all day if you want to. But a key for viability can be governance. A good example for this, one of my favorite examples, is Blender 3D. Blender is a project to edit 3D objects. It was, if I recall correctly, French. The company was going down, but the project was used, the software was used by a lot of people. So they did a crowdfund, they bought the IP, and they released it under an open source license. It's now one of the most sustainable open source projects around. They're huge. Success is not also restricted. If you want to measure success of an open source project, you don't have to restrict yourself on the maximization of profit, because open source intrinsically generates and distributes value. Yeah, one of my favorite diagrams that we shared on that report is that an open ecosystem actually provides for more standardization and more innovation, and allows new entrants to enter the game, new people to do stuff. We've seen it in the server domain with open source, and we believe that we can see it in the space domain with what the people attending this conference can do. We identified around 7 open source development modules, and if you want to say business models, they are not exactly business models because they include considerations on licensing and on community. Usually, one of the most prominent ways to do open source right now is business to business, like Android does or Capella does. That was mentioned a little bit ago. Okay, control ecosystem like WordPress and SatNOGS, maybe, I don't know. Common upstream ecosystem like OpenSSL or ORCID. Ethically open source projects like Diaspora, good old friends Polyastro. Open hardware projects like Arduino, HackRF, opportunistic open source like code apps from big organizations, governments, etc. Mass market open source. Good old Firefox and Flickr, for example. Anyway, we took these models and we wondered how actually are applied to satellite communications, but we first had to define satellite communication domains. So we have comms payload domain and test integration in space. We have design and analysis in the mid, and ground segment and user segment technologies and downstream applications on the ground segment. So we surveyed several projects, and we found out that the development methodologies they use are these. I will go really fast because Manthos will start saying that we don't have enough time. I totally suggest that people check out the report. So, what we did identify there are around 68 software projects, just 3 hardware projects, 3 standards that we could use, and moreover, the thing we did identify is that from the projects we surveyed and we focused on, oh, thanks a lot. Yeah, Red is giving out a link on the chat on OpenSatcom.org that will allow for a better understanding of all the projects we identified. Note that some might not be actually open source, and that's an issue we identified, but they're included in order to find out how the industry is going. But the vast majority of the projects we surveyed are open source. So, taking all these into account, we created a website and released a report, and we are on the process of bounty support for open source satellite communications projects. If you have some good ideas and a good defined bar that you like to share on a satellite communication project that's open source, ping me or Keros or Manthos, we are around. And ORCID Polyester is working on a constellation definition designer. And we are going to work on a survey on adoption expectation, on how people are taking into account open source in satellite communication. That's all from me. I would like to hear your questions, ideas, inputs, whatever.
Thanks a lot, Elif. Thanks a lot. I shared the link to your report.
Thanks.
And I hope you don't hear me twice. I hear me twice. I have a little bit of echo.
Oh,
that's okay. Okay. And then I made you presenter, Mantos, so you can do your magic in the backstage. So LF, maybe we would have some questions around here. I always like those projects where you're actually trying to fill the gaps. Here it's in satellite communication. You know, you've seen like when you want to build a fully open source CubeSat, you know, you have to go through software, but also through hardware. Is it also something you're covering in all those projects?
Indeed. I suppose that the most important thing is to find out a way to understand that open source makes sense, and makes sense especially for big organizations that are working on space, because it can provide solutions and a very good framework for collaboration. A very effective framework for collaboration.
Indeed.
If there are any questions, I will be more than happy to answer them.
All right. Anyway, you'll be around the 2 days, LF, if I understand right. And even more, you're on all the channels here and there. So from machine learning projects to...
So I'm almost omnipresent.
Thanks a lot, Eleftherios. Thanks a lot for your time on this. This is good. So, yeah. We have to applaud every
Bye, guys.
Just remind me you have to upload and just turn on your microphone and do it. It's okay. Next to speak will be Michael Brady, talking about the progress in electric propulsion. So he's a physicist, and for his hobby, he's also a physicist. but for space. So if you could see his garage now, I think if you follow him on Twitter, you'll see everything. You know everything about his garage, and it would be presenting the recent progress he did with applied ion systems that he funded quite recently. Was that last year, Michael? You funded. Yeah. Okay. I can't hear you very well. You're kind of very low on sound. So you got a fan already on the chat. This is good. I can't hear you. Can somebody hear Michael just to see if that's just my problem? So we can move on. Can't hear also Konstantinos. Okay. Okay. No, it's still not. Not even a robot voice. Take your time. We're here. You can switch microphone. Is okay, so we will take his electrical propulsed microphone. It's very neat. Good. So we're good on time. We're perfectly on time. So the next one will be also Anastasios Faldon. Okay, Michael, you can test again. I see you have earphones. Make a thumb if you can hear me. Good, great. We can't hear you yet. Is that just me, Boris, Konstantinos? Can you confirm?
I confirm you can't hear.
Okay, okay. We still can't hear you, Michael. If you need some more time, we can switch presenter maybe and do the next one. Need some more time setting it up. You can also talk via the closed caption by writing, but that's not very efficient. So let me just check. You're well connected with BBB on the microphone. I don't know if you did the echo test. Did you unmute everything from device to keyboard lock and everything? Pulse audio. Okay. Just as a matter of information, is Anastasios in the room for the next presentation on A-CubeSAT? Or anyone? Yeah, oh, Konstantinos, you will be speaking. Okay. So maybe, Michael, we switch to Konstantinos. We come back to you, if you don't mind. And try. Do not hesitate to try the microphone even while Konstantinos is speaking. I believe you will understand. Konstantinos, so we'll start with you then. Yeah, please switch your microphone on. That'd be great. So, and for the little story, Konstantinos is representing the A-CubeSAT team today. Is working at is a student at the Aristotle University in Thessaloniki in Greece. I hope I pronounced it right. And they have a 3U CubeSat hosting a biological experiment. So this is pretty cool with the pressurized containers. We would love to hear more about that, Konstantinos, how you're managing all this, and what's the room of open space over there.
Okay. Hi, I hope you can hear me. So
perfect. Yeah.
Okay, great. You caught me a bit unprepared, to be honest. So
right. No.
Yeah, I'm gonna mute my phone and get started right away. So yeah, Thessaloniki, as you very correctly said. So this is our project. Some of you may remember us presenting it last year in OSCW 2019. So this is a bit of a progress update on what happened since then and what we've done with our project. So this is our CubeSAT, this is our mission, this is our team, about 40 students, mostly undergraduate students from the Aristotle University of Thessaloniki, as well as some other universities around the world. So we are developing a CubeSAT mission. We've been developing this since 2018, this specific mission. Our target was to enter the Fly Your Satellite program by the European Space Agency, and this year, in February 2020, we managed to get into this program. So we're gonna see a little bit about more information about this as we move on. So, as you know, this year has been a little bit hard for everyone. So we were working mostly remotely. You can see sometimes we did go to our beloved laboratory, but most of our work was done in Discord, actually. Unfortunately, it's not open source, but this model of having rooms and being able to simulate this coffee break style between meetings and not just having the typical Zoom or Big Blue Button sessions where everyone goes and then everyone leaves and they say nothing to each other all day. So this was a very nice experience for us. But let's get started with the technical stuff. I think most people are interested in this. So this is our CubeSAT, a 3-unit CubeSAT. Its mission is a biological experiment, as Red said. So we're starting gene expression on yeast strains, on eukaryotic cells, on Saccharomyces cerevisiae cells. So these are cells that have a genome similar to, or with results that can be also applied to human cells. So our final target is to extrapolate those results for human biology in space. Our system is a combination of commercial off-the-shelf and in-house subsystems. We'll see more about this in the next slides. We're estimating our loads in 3 years from now, I believe. And as part of the open source philosophy that we're trying to follow, we have started uploading parts of our critical design review, which we had to deliver as part of our participation in the Fly Your Satellite program. So if you visit this link, I don't think it may be clickable for viewers, I'm not sure. So if you visit this link, you'll see that we've already uploaded some documents, whatever we are allowed to publish, and we'll continue updating and even uploading more in the next days, months, years. So this is our satellite. You can see the solar panels. You can see the heart of our satellite, essentially. This is our experiment. This is our payload. This is where everything is hosted. And these are our subsystems. And here you can see in a little bit more detail. So let's get started right away. First is the science unit, the payload, what we call. So this is the pressurized container that Red mentioned before. The payload vessel, this is 1 atmosphere. This is the air that is needed for the cells to survive. We put those cells in a microfluidic chip. So this thing right here, you can have a sense for scale. It's about this big. So this is a new development made by us. You can even see the designs here in this repository. We take photos like this one, a little bit different. This is a bit outdated. And using this photo, we see cells that fluorescence. So they generate light. And then based on this light, we can see how its gene is expressed. So we can have very large-scale results for space. This is a very large-scale mission compared to the previous one. So we took the ideas from previous missions and we kind of multiplied them, but in a smaller size scale, but larger result scale, if I can say that. And this is, the idea is to provide a modular experiment that can be used also by other missions and very quickly and in a very low cost extract results in space for biological aspects. So more technical information about this can be found on our previous presentation, I believe. But I'm going to just move forward and move to the other subsystems. I'm sure many people here are interested in the communications aspect of things. So I'm going to put a little bit more of attention to this subsystem. So for communications, we are using the SatNOGS comms board, which is currently under development by the LibreSpace Foundation. So this platform is essentially an SDR board that supports operation in 2 frequencies at the same time. So the first frequency is the S-band, the 2.4 gigahertz. We have a custom patch antenna that is designed to support this. With a high data rate for our payload data. And then for our more robust link that doesn't need any pointing accuracy, we are using a deployable antenna, a dipole antenna. This is based on AppSat's deployable antenna design, but with a few modifications. And it's in the UHF band. Of course, all data here will be accessible to any radiometers or any users of the SatNOGS network. So the details of the antenna design, the details of the packet structure that we're using, the CCSD, CCSS packet structure, these are all available in our CDR. So in theory, everyone will be able to receive any data. Again, also as part of the SatNOGS network. So moving on to some more subsystems. This slide may take some time for you to load, but don't worry. For the ADCS and OBC, these are subsystems we develop in-house. So we have a double-sided ADCS and OBC board due to size constraints. You can see these are the both sides. Okay. Again, for the OBC, a little fact that I'd like to pay attention to is that we are using a radiation-tolerant microcontroller by Microchip. So this is the SAM V71 Q21RT, I believe. So this is a radiation-tolerant model, which means it's on the expensive side of things, but the positive thing is that there is a non-radiation-tolerant version. So in the interest of modularity and reusability, someone who wants to use this platform on their own mission, if they want a low-cost approach, they can use the non-radiation-tolerant version, and it's exactly the same. And if someone wants to do some interplanetary CubeSat missions, for example, like we heard in the previous talk, they can go for the low-risk approach and use the radiation-tolerant version. So, and again, the schematics and the software are available on our GitLab repository. So moving on to some other subsystems. Here we are starting to go into the more code side of things. So due to lack of engineering hands available, I would say, we are procuring these subsystems as COTS components. So the EPS and the structure are mostly from manufacturers like EnduraSat and ISIS. And again, you can find more information about trajectory analysis or power budget. For example, we've made kind of a dynamic power budget in this link as well. Now, another aspect of the program, of the Flyer Satellite program that we would like to share with the community is the systems engineering side. So this is something we don't often see in open source projects in the more agile side of the spectrum, I would actually say. So this is again something we've tried to share, and I will start from the requirements, which is ideally the baseline, the starting point of every space mission. So for the requirements, we've uploaded our entire specification. It's about 200 requirements, I believe, and again, everyone can access it. And we've made this cool requirements tree, so you can see which requirements have parent requirements and child requirements, which again was not easy for us to find. We move on to more analysis. So, for example, we have the failure mode effects analysis, the FMEA. Some of you may know it. So we list every component. We list in what way it can fail. This is pretty standard in aerospace. And again, you can find this analysis online. It's been extremely useful because we don't just take stabs in the dark, hoping that, okay, a satellite will work, but we see its component, how it can fail, and how much risk it can pose. This is a bit time-consuming. This analysis takes a long time, but I think in the end it is worth it. Moving on, some more funky aspects. Our hardware-in-the-loop testing platform, HIL platform as we call it. So we've placed a microcontroller in our lab, and everyone can program it from our team remotely. They can submit and put a merge request in GitLab, and the code gets executed in the microcontroller. So, for example, our implementation of VCSS services is automatically tested on this microcontroller. So we can see, okay, if I get something that works on my laptop, does it also work on the ARM architecture? And how fast is it? So you can see here we have some very rudimentary benchmarks. So again, this is something that is close to the verification aspect of what we need to do. And then we have this more operational aspect, these more operational plans and diagrams that explain the function of our satellite in detail. And again, this is something that is constantly being updated, and we try to keep it as public as we can. So thank you for watching us. So again, we're trying to keep our developments and our designs as open source as we can, given all the constraints and the commercial equipment that we are using. and we hope that many other teams can use our information in the future, as we've used information from other teams in the past. So, for example, the A-CubeSAT mission by LSF has been a major starting point, even unconsciously, I would say, for lots of our progress right now. So, yeah, thank you.
Very nice, Konstantinos. I think that's all of that. Well done. Thanks for jumping in quickly.
Thank you.
Awesome level of details, actually, in a so short presentation. We feel like we were in your team. This seems like very challenging. This cell in the middle is taking so much room, so it's going to be a challenging operations, I believe. Maybe we have the first question from Michael, just to test your microphone if you want. But if you have questions over here, am I in the public chat? Yeah. Yep. I shared your link on GitLab. This is nice. Okay. So do you have biologists in your team, Konstantinos?
Oh yeah, we do have a lot of them, actually. The people who started this experiment were medicine students. Now they're postgraduate bioengineering students, I believe, and we have many people from these departments, and they need to have a very close collaboration. A very close collaboration with the rest of the systems engineering disciplines, I would say.
I can imagine. So there's a question from Samuel. I can ask it. He's curious. What do you think you will expect to find in the gene expression of yeast? And do you guys have a hypothesis so far?
Yeah, I am also not a bio guy, so I won't give you a 100% correct answer. Now again,
bio guy either.
yeah. So again, the point is, the point is to find that there are 5 pillars of human biology and human medicine in space. So I don't remember all of them, but it's the lack of gravity, it's the lack of it's the radiation. So we want to find how all these space conditions can have an effect on cells and on genes. I don't know if any studies have done on this scale yet. So maybe the answer is we don't know, because I think the largest amount of studies done is for it's for the large scale. The human, for example, the twin study by NASA. So we're trying to see if and what effect this has on cells. We've already done some radiation tests to cells, for example, and we see that, of course, the DNA can change. There's DNA damage.
Yeah.
So maybe the answer is we don't know.
What would be the impact on human cells there? That's the thing. Right?
Yeah.
That was the question from Samuel. He's typing again. So that's. What's the most challenging to open source in your project so far?
You mean from the programmatic or the technical part?
Whichever. What is the most challenging? The one that keeps you up at night when you think about it.
Well, a lot of things I would say. So, for example, for structures, there's been a lot of work, and it's been really hard to share. Because we're using a commercial structure, and we're doing our analysis on commercial structure. Even if we do our analysis for our vessel itself, we really need to spend time to correct it and find everything that is confidential and upload it. And these last days we tried to upload our CDR, and we have to pay attention to every little value. If some manufacturer shared it with us with an NDA, we cannot upload it. So, yeah, it takes some time, but it's worth it in the end.
You have some logs, but you need to step over there. That's good. That's good. Anyone has another question to Konstantinos? Anyway, Konstantinos has been in the channels for some time. He's very active. You can always find him there. And when is your launch planned so far, Konstantinos?
Yeah, our launch is for 2023. Again, this depends on the launch opportunity, so nothing is standard yet, but this is the general idea.
You don't know the rocket yet, right?
Yeah.
Okay. 2023, we'll look for that. Looking forward. Good luck on the development. And
thank you very much.
And keep us posted. It was good to have some bio biosatellites in orbit. Like it's a mini lab you're sending. That's great.
Yeah, it's called lab on a chip. This is the the fancy term.
Yeah. That's a good one. Okay, Konstantinos, thank you very much.
Yeah, thank you very much.
Follow you again. You can turn on your camera, Michael Brady, in the meantime. Mantos is preparing your presentation, and we can try to your microphone, Michael.
Can you hear me now?
Oh yeah, loud and clear.
Okay, good. Yeah, I have the computer microphone strapped to my shirt now, so hopefully this works.
Great. Okay, so I already introduced you, Michael. We know you created applied ion systems quite recently, and to support your research on thrusters, but also I know you're on some. You have some missions using your thrusters already, so it would be great to hear about the progress and developments in open source propulsion in that sense. So with no further ado, Michael, the screen is yours, and take it away.
All right, thank you very much, Fred. Yeah, so my name is Michael Brady. For those of you who don't know me, I'm the founder of Applied Ion Systems, and today I'll just be sharing some progress and developments in open source electric propulsion through my work at Applied Ion Systems. So jumping right into it, at last year's open source CubeSAT workshop, I presented some of my first systems that I started working on last year. So it was the GPPT-3 pulse plasma thruster. That thruster was slated to be integrated with the AMSAT Spain Genesis N and L pocket cubes. So since that presentation last year, they have been successfully integrated into just pocket cubes. They've passed TVAC and vibration testing, and they are currently loaded on the PicoBus deployer, waiting for launch, hopefully in this December. They were supposed to launch last December, but there's been a bunch of delays. So hopefully we'll actually have finally some of the first, as far as I'm aware, open source thrusters firing in orbit, and we'll have some data for that. So the moving forward from that development, this is one of the thrusters I worked on this year. This is the EPPT-1 micro pulse plasma thruster. So like its predecessor, here you can see all of the electronics in the thruster are on one single board. This is slightly larger than the GPPT-3. It's about 45 millimeters squared by 28 millimeters deep. So still very compact, aimed for pocket cube class systems, but also able to be integrated very easily into a CubeSat system as well. So some differences and improvements for this design was spring-fed fuel as opposed to just the Teflon bore that was used in the prior system. More efficient power supply, a more robust capacitor, which was the main limiting factor of the last system, using dual ignition transformers and an improved thyristor. This thruster also utilizes 3D printed housing, so I experimented with Ultem 3D printed material, which allows a lot of built-in modularity. So it allows me to house all the the electrodes, the connections internally, and the fuel itself, and allows it to be expanded for higher housing, for more fuel capacity. So the goal of this thruster was ultimately longer lifetime, modularity, higher thrust, and just an overall better working thruster. So here you can actually see a shot of the thruster firing, and for this and all my other thrusters that I present here that I actually built, there's plenty of video and documentation available that you can view for these systems. Unfortunately, I stopped development of this thruster because there was a lot of issues with the 3D printed systems in terms of compatibility with a high voltage and high vacuum, and a lot of arc-through issues. However, this has given way to a hybrid system. So this is combining the GPPT-3 thruster head and the EPPT-1 electronics. So here you can see a couple of different iterations testing different main capacitors as well as ignition pulse transformers. So this thruster was much more successful than the EPPT-1. Here's a shot of it actually firing. So I was able to fire the system overdriving the electronics to a rate of 4 Hertz, which the GPPT-3 was operated at 1/3 hertz. So a significant improvement in terms of thrust and output power, and still very low power system at maybe 1.5 watts, whereas opposed to the GPPT3 was operating lower at about 0.5 watt. So this development is still currently going on. I am currently exploring ways to improve thruster reliability and getting the system firing more repeatedly and long term. So next we have a quite exciting thruster that I've been working on. This is the AIS-ILIS-1. So unlike the prior thrusters, this is an ion thruster, whereas the prior thrusters were pulse plasma thrusters. So this is an ionic liquid ion source electrospray thruster. So this utilizes room temperature molten salt for the fuel. In this case, EMI BF4. So like the prior thrusters, again, you can see all the control electronics and the thruster with the fuel tank itself all together on a small board. So the system is very compact, again, 45 by 45 millimeters, 16 millimeters deep, very low mass, 1 gram fuel capacity currently. The fuel is EMI BF4. And for these types of thrusters, the fuel is held in a porous glass reservoir. So you can see kind of the thick layer in the center of this diagram. And that is passive, a porous glass emitter. In this case, I have seen during the most recent testing with the V7 prototype, I achieved a peak thrust of about 3 micronewtons with a operating voltage of about 5.8 kV, giving me about 4,500 to 4,600 seconds of ISP. Very, very low power system. And one of the great things about electrospray is its ability for scaling. Electrospray is one of the few technologies that has very high performance at a very, very small level. And these even individual emitters can be down to microscopic levels, which this tries to avoid by using newer developments in ILIS technology with CNC macroscale emitters. So this thruster has been fired multiple times in vacuum over the course of many iterations. Well, here you can see an example of the porous glass ridge emitter and the 3D printed Ultim housing. So this is before the glass is actually saturated in the fuel. And if you follow my developments, you'll see that I have a fueling procedure as well as the actual testing procedure for preparing the system. So here you can see the ion beam being emitted from the thruster. There's still a lot of work to be done on this system. There's definitely a lot of challenges with lifetime and emission stability. However, there's a lot of exciting promise for this system in the nanosat world, and lots of other people exploring these types of thrusters as well. So one of the nice things about electrospray in general, whether it be FEEP, ILIS, or colloidal, is their ability to scale and has great modularity. So here we can see kind of an example concept for a CubeSat cluster. So you have 4 individual Pocket Cube systems mounted onto a central control board that would allow you to control each of the thrusters separately and provide more performance for CubeSats. A single thruster could also be used for a CubeSat, but this allows you to scale up easier and get more performance for larger satellites. Here is kind of the ultimate where this system is hopefully going. This is the AIS-ILIS-2, a little bit higher power than I've been running currently, but the goal is to achieve greater than 20 micronewtons of thrust at greater than 3,500 seconds ISP. So still a very small compact system, compatible for both CubeSats and Pocket Cubes. And as opposed to the original emitter, which was a single ridge, which is much easier to machine, I'm aiming for a large array of micro spike, or still CNC machine spike emitters to give me more emission sites and better control of emission characteristics of the thruster. So moving on, I'm getting more into some conceptual designs now for systems that I would like to explore for CubeSats and larger satellites at higher power classes. So this is a design project that I started early in the year. This is the AIS-IO series, and this is focused on a modular, low-cost, solid iodine-fueled thruster. Now, if you know electric propulsion and conventional thrusters like Hall thrusters, gridded ion thrusters, RF plasma, they use some sort of gas, typically xenon. Now, one of the challenges for using conventional gases are that you need pressurized storage tanks, you need fuel delivery valves, and this can add up a lot of cost and complexity, as well as has some issues for secondary payloads for integration with the pressurized system. By using a solid fuel that can be sublimated, this eliminates the requirements for pressurization. So here you can see two of the thrusters variants, and one of the core of the IO series concept is the modular ionization chamber and fuel delivery chamber. So at the back, you actually can see a heated fuel chamber where there is a pressure plate, there is a ceramic heater, and that sublimates the iodine fuel, which gets fed directly into an RF excitation chamber. And the goal of this system was to have it modular so that it can support really any sort of conventional thruster system, whether it be gridded ion like on the left or RF plasma on the right. And all that's really required is to change the output of the thruster and some connections on the board, which would also be kind of a universal drive board. Now, this is all great on paper, but one of the challenges with iodine is that it is extremely corrosive. It corrodes most materials, both plastics and metals. So it's a really challenge to work with, as well as kind of a hazard to work with. So I've been searching for a long time for some sort of low power requirements, low temperature solid sublimation fuel to kind of replace this. And I stumbled across a very potentially exciting and experimental fuel in the electric propulsion, which has led me to my most recent thruster series design, which is during this presentation, this is actually the first time I'm revealing this system. So I am pleased to actually present the new AIS Adamant series. So this is an experimental, ultra-modular, low-cost electric propulsion solution to support a wide variety of plasma and ion thrusters. So again, this is taking the principles of the IO series and further refining it for this new fuel type. So we have an ultra-modular design, very universal fuel delivery system with a plug-and-play fuel cartridge that's also standalone and highly compact. No pressurization, again, because it utilizes an experimental low sublimation point fuel with a very simple connection to various thrusters with a simple adapter plate. So again, the core of this design is the sublimation fuel tank. So the fuel that I have actually selected is adamantane fuel, which is where the adamant comes from in the name. So adamantane is a special type of diamandoid hydrocarbon that has similar sublimation properties to iodine. And this is very exciting because it can be delivered at a low power directly from solid form without the need of pressurization, but it also doesn't suffer from any of the issues of corrosion. So now we have a relatively less toxic and more material compatible fuel. And there is very limited research on this. This is a very, very experimental fuel. There's very little literature on it. But from what I've seen in some reports, particularly the one from the University of Southampton, is that it actually has almost identical performance properties to other fuels like xenon, krypton, and iodine. It is ruled out by a lot of other studies just because they have access to these more conventional fuels, and the plasma formation as well as the ion species are incredibly complex, making analysis and stability extremely difficult. But I think at least at this scale, since the fuel is readily available, relatively low cost, and safer to work with, this allows a lot of exciting potential to open up for these propulsion systems. So again, this is aimed for CubeSats and larger satellites from the 10 watt class to over 1 kilowatt class. So highly scalable at hundreds of micronewtons to millinewtons of thrust. And this again is to support any sort of conventional gas-fed electric propulsion system. So anode layer ion thruster, Hall thruster, gridded ion, RF plasma, microjet, anything that any electric propulsion that relies on conventional gases that you typically see like xenon would be used with this system. So here you can see the basic design. There's the outer casing. There's an inner housing with a ceramic heater on the bottom and a pressure plate, and then a pressure plate to compress the fuel, and then fuel delivery holes to allow the sublimated fuel to go directly into whatever propulsion system is mounted to the top. So here is actually an example. This is going to be the first experimental thruster I work on using this adamantane fuel system. So this is an anode layer ion thruster, which is similar to the tall hollow thrusters, except this is more the conventional industry version for an anode layer ion source. So you can see that the thruster head itself is directly mounted to the fuel tank. There is an adapter plate which would be adjusted based on whatever thruster system would be mounted to it. So I'm also working on a higher power design, a cylindrical Hall thruster for the 50 to 100 watt class for CubeSats as well. So again, the fuel is directly sublimated from the tank and is delivered into the thruster backside directly. So this will be a very exciting development, getting now more conventional systems. Typically, you know, if you're looking at Hall thrusters or gridded ion thrusters, you're talking about hundreds of thousands of dollars. So I'm looking to reduce the cost of this by orders of magnitude and make these technologies more accessible with a very exciting fuel that will potentially, hopefully, help eliminate the need for pressurization and really explore this new fuel source further and provide more data for the field, where it's very, very limited currently. So you can follow these efforts and collaborate, contribute. My main channel is Twitter, where I do live testing, where I post things regularly, update designs. There's the Applied Ion Systems website with all the documentation, as well as other platforms that I am on. You can also contribute to this project. Currently, everything is being funded through the AIS Patreon, which I would not be able to have continued these efforts throughout the year without the amazing support of enthusiasts around the world helping contribute to bringing open source electric propulsion to life. So with that, I want to thank you for listening to my presentation, and I look forward to answering questions you might have.
Great, thank you, Michael. I think we clap that. Yeah, impressive. Thanks a lot for sharing with us all this. And actually, this new design looks very, very neat. So why did you go from squared to actually cylindrical, even though maybe the casing is squared in the end? But
So those were very different designs. The original kind of square thruster was the pulse plasma thruster, and that was a way to make it simpler to manufacture, make it super, super tiny for pocket cubes. But the new adamantane series, like the prior IO series, was really geared for CubeSats, so I have more room to work with. And in that stage, the cylindrical geometry for more conventional propulsion lends itself better just for manufacturing.
That's amazing. I got some questions actually I've seen on YouTube, and because you're using adamante, which is you mentioned quite a classical fuel, or maybe non-academic, or I don't know how to mention that. But questions is where do you get that? Where do you get adamante?
So like the electrospray fuel, which is an ionic liquid. You have to get it through chemistry suppliers. So I've gone through general or specialty chemistry suppliers for that, and the adamantane is also available from the same suppliers. So I'll be going through those sources again to acquire the fuel for experimentation. And for the very beginning stages, I'll be using very, very small amounts. That's also kind of the nice thing about electric propulsion is you can use, you know, a gram of fuel or something and really go a long way with it. So I have located the source. I think Sigmund Aldrich is one that carries it. So I'll be looking to probably purchase some and start developments on the fuel tank hopefully very soon.
Okay, thanks for your openness on that question. You said you've been supported, so you have a Patreon. So do you plan to make another campaign over there, or it's always open?
Yeah, no. One of the things that I've really decided on with Applied Ion Systems, now that it's kind of an official company, and actually today is the 1-year anniversary of Applied Ion Systems being an official LLC, is really, it hasn't changed much from when I was doing this as a hobby, because I'm still doing it the same exact way in the basement, running the stuff. Nothing has changed except now legally on paper. And everything I'm keeping it still open. Everything is open. I'm posting everything the same exact way. I do live streams of testing, and everyone sees all the successes and failures, and I launch the designs just the same. So I plan on continue keeping everything open.
This is cool.
Through my own efforts. And
I'm watching your live streams until I realize they are 2 hours long, but that's really cool.
yeah, and a lot of times the recent live streams have been pretty boring because I've had a lot of failures and things haven't been going right. But it gives people an opportunity to see that, you know, it's not all peaches and roses all the time.
Of course, it's nice. We have a question from Samuel. Actually, curious, how did you manage to measure micronewtons? So you said that your first thrusters that top at 3 micronewtons.
So in my actually in last year's presentation, I shared a very simple way of measuring at this scale is using a little micropendulum. So I have that directly mounted inside the chamber. It has a little 1 centimeter square Kapton flap with a very, very thin wire. And by knowing the mass of the flapper as well as the direction or the amount of displacement, you can actually correlate that to force. And that can also be kind of done as well for some of the larger thrusters as well as the continuous thrusters. But for some of the things like the ion thrusters, you can actually indirectly measure thrust by looking at the beam current. So I have another tool, Faraday cup, just a copper cup in there that the beam hits, and by collecting the current and by knowing the properties of the fuel and the acceleration voltage, you can estimate the thrust being exerted from the thruster.
Very nice. I hope that answers your question, Samuel. Do not hesitate to ask questions, people in the room. Maybe we have more questions on the YouTube channel. Just let me check. Yeah, where do you get that from? That was already asked. Another question from me, Michael, is who is using your thrusters at the moment? So do you have users, and do you have plans for the future that are coming up?
Yeah, so obviously AMSAT Spain are using 2 of my thrusters. I am in talks with another group to potentially use it, which I can't disclose yet.
No, please.
But yeah, and there's also other talks, other talks as well for using some of the pulse plasma thrusters as just general ground testing sources. So I've kind of, for the pulse plasma thruster development, I'm kind of moving towards very low cost open source test modules for people to be able to access this stuff better. And I've also, over the past year, partnered with Citadel Space Systems in the UK to work on bringing the electrospray stuff up to for some of their systems they're working on. So several channels being explored for the thrusters, and hopefully we'll see some more next year in space.
Yeah, that's nice. Yeah, that's very nice. So wish you the best for that, actually, Michael. I know you're around on some channels. Where can we find you? You already have those links. Are you on the Matrix channels, or you can't be everywhere, right? But
yeah.
It's okay. So we know where to find you: LinkedIn, Twitter. Michael's always responding, so please do not hesitate to reach out to him. If you have a mission you want to know if you can integrate the new thrusters, I think you can reach out to Michael too. And I think bit by bit, I see you becoming an industry player somehow at some point, because this is kind of a gap. You know, it's hard to know how to thrust a CubeSat or small sat. Actually, you've been working with Pocket Cubes, so it's quite some work. So thanks a lot, Michael.
Yeah, thank you.
And I think we'll break out to room 1. You can stay here. Everybody from room 2 will come in, and we will say hello. So perfect. Thank you, Mantos, for sharing that. So we've seen amazing things. That's very cool. You can turn on your microphones. You can chat. This is it's like a small break starting. When everybody comes from room 2, we will announce some messages. Yeah, well done, everybody.
Bravo. As well.
So Mantos, where's room 2 at?
They're a bit back, I think, but
okay.
Yeah.
Did they join already? Or right.
Yes, I think they are asking questions of the last presenter.
Red, by the way, I would have a question.
Go ahead.
We were asked a lot of things about docs and blah blah. So maybe we could make a reminder as a slide how to contact us and so on. So will be there any slots that is more adapted for that? Maybe in the how to contribute to open source, or I don't know.
You can do it now. Let me.
Well, we can prepare something to remind
Yeah. Do you have one of the? Yeah, if you want to do that later, please. Yeah.
Okay.
During the breaks, you can use that room, and at the end there'll be some time where you can do that.
And thank you all for your questions. So they are really appreciated and welcome because they help us to focus on the right needs.
Yeah, it's true. Very cool.
I got back online very late. Was Boris asking about the talk on how to contribute to an open source project?
Yes, I was wondering if it is whether there is a slot to remind some contact mails and so on. But maybe it's not the right slot. I don't know.
Yeah, you can do it during the break, which is starting in 3 minutes.
We'll try.
So, yeah. And you can have the room for that. Anyone, if you have special needs like that, please tell us, and we'll make you presenter. We'll share your slides on the screen.
Okay, we try to do that for the end of the break.
Yeah, sure.
It needs to be done.
Anyway, at 6:10, at 6 we'll have the recap, and at 6:10 we'll do the virtual hangout where you can actually share anything there for at least half an hour. So that would be also a good time.
I guess all times UTC, right?
Yeah. Yeah, sorry, 6 is CET, so I think speaking in Boris time, maybe. Good point.
Sorry for that.
Okay, no problem. We have people rejoin, I see. How's the room 2 going, LF Montos? I can join there, but
I think they
give a
finished.
short recap. So on this room 1, we had State of the Union of SatNOGS, thanks to Freddie, an update of docs development with Boris, Ashika, and Thibault. Open SATCOM report and findings with Eleftherios. Progress and development of AIS, sorry, Michael, applied ion systems for micro propulsion systems, electrical propulsion systems, and Konstantinos, thanks for jumping in quickly on the A-CubeSAT, so to probe gene expressions in low Earth orbit, and very good and detailed presentation. Thanks for that.
Room 2 is on the last presentation's Q&A.
All right. So maybe we can have a break, and we can have a bio break. I need that too, and I'll be back when they come back. See you soon. I don't know how to put music, but I think it's better if you put it locally. Now this is room 1. Just a quick reminder of the hashtag you can use on social media, because we're tracking and retweeting you, so do not hesitate to use that. Actually turn on to user dashboarding. Feel free to express yourself. I trust you. Reminder, you're live streamed. Spaceship. Well, well, well. Oh, you're so creative, guys. This is nice. Even see a Polaris graph. Hello, everyone. So we're going to start the lighting talks. Just a quick reminder, we still need some of your presentations to be there, so please send them to info@OSCW.space. We need that ASAP so we can smoothly switch from one presentation to another. Okay, so how this will go on. So we have like how many? 1, 2, 3, 4, 5, 6 presentations for those lightning talks. Each one of you has 4 minutes to pitch your idea, project, or whatever it is, and this will be 4 minutes sharp. So your microphone will be turned off. So I will warn you at 1 minute left. Me or Montos. So take care of this. Are we all ready? Can you say hey? Can you say hi? You.
Hey.
Yeah.
Yo.
Hi.
Hi. Good. Good. Very good. So if you're ready, then we're going to start. We're 4 minutes left. Late, but that's okay. We have a buffer after that, and this is with Arthur. So Arthur, go ahead with your 1U PCDU. The screen is yours, and you have to turn on camera, yeah, if you wish.
Then I do that.
Yeah, as you wish.
So, going to present this 1 unit power conditioning and distribution unit. And let's first think about what is a PCDU, because it's a abbreviation that maybe that's not so familiar to many of you. But PCDU is an integral part of an electrical power system, so EPS. Well, EPS is the system that supplies your satellite with power, and an EPS usually is composed of input power, that's solar panels, and a way to store power in between. And for this we use batteries, mostly lithium-ion batteries nowadays. And the PCDU really is the thing that manages those 2 components, so the power source and the power storage, and then provides stable output power to the rest of the satellite. So there's, since the power system is the most critical system of each satellite, without functioning power system, you can just launch a stone. So that thing must work, and there's a lot of systems that are being developed. So why yet another one? Well, the reason is we want to create a very robust but yet simple PCDU that is also modular and can be extended by you. We focus on a single output line that's a 5 volt. So a single output power voltage, no 3.3 volt is included here, because this one you can create locally using low dropout voltage regulators at the points that you need them. So the advantage is we focus on providing a really stable and powerful 5 volt line, at least 5 watt, maybe hopefully even more. And it should be completely fail-safe. So if a component fails, then that should not lead to a failure of the system. That's the concept of redundancy. And the other unique feature is probably to have this CAN interface for commanding and monitoring. Here's the schematic. Well, you probably will not be able to decipher any details here, but you can look into the repository just to show you here that everything fits on one sheet of paper, if the sheet of paper is large enough. And here's some more details. So here's the input section, solar panels. I have 1 minute left, I know. The regulation of the input, the battery chargers. Here the stable output power, switches here, and here's the interface to the monitoring and control unit. Here's the prototype we have developed so far. And yeah, the next step would be to integrate this CAN interface. So the microcontroller, select the microcontroller for this project, maybe STM32. And then once it's done, test it and finalize the PCB. Yeah, would be happy if you join the project and create the first robust open source fail-safe power system.
Thank you, Arthur. Thanks. You know where to find Arthur. It's very cool. So no questions asked, but one, how did you like that? You have to say yes in your microphone if you liked it. And the louder it is, the better it is. So I can expect some yes.
Yes. Yes.
Yes. Very good. Very good.
Yes.
So Louis, you will be next. So Louis, where are you?
I'm here.
No, I mean where are you situated? Where do you work?
I'm in Paris right now. I work with Boris. Maybe you know him.
Yeah.
And
so
yes,
cool. So Louis, this is your 4 minutes. Go ahead. And
I don't know if I have access to.
Okay, sorry. Presenter role. 4 minutes haven't started. Don't worry.
Fine.
Can somebody find him? Yeah. Make presenter. Go ahead.
Yeah.
At the bottom. Perfect.
Okay. So yes, hello to everyone. So yes, I'm Louis, and I work at the CERES Space Pool of PSL University in Paris at the Paris Observatory. And I'm going to present you an issue that we had and that we still have somehow with our ground station as a newcomer about to demodulate data. So right now you know of SatNOGS network, and our ground station has been part of this network for more than a year right now. So we're located in Paris, of course. With our station, we made more than 6,000 observations during this time. And so we can say that we have a quite good station at the moment. And thanks to this station, we can receive many transmissions from various CubeSats around the world, and we can forward the data to the SatNOGS network and to the dashboard of different CubeSats. So basically, what is I might say a good observation? So let's take the example of the NOAA CubeSats that you might know of. It's weather monitoring satellite, and basically what we have here is called the waterfall, and it can be transcripted as a demodulated data here as a raw data. Some images we can see really clearly, but it's some images of the weather. So basically this is what we can call a good observation with demodulated data accessible on SatNOGS network. But recently, the team in Grenoble University, so in France, they launched their own satellite called A-CubeSAT, and they asked us to, if possible, observe their CubeSat and give them some data. However, we found out that we had some issue with their data, and especially how to demodulate their data, because we had some, as we can say, good observation with clear signal received, but yet we couldn't provide to demodulate data. However, an example on the SatNOGS network of we can call a good observation with good data. Thanks, Alexander Bars, for this beautiful example here. So we should have some demodulated data on the A-CubeSAT. So we know there that we had an issue, but it was not on the side of the station. So it was about the decoder of for the A-CubeSAT decoder. So we tried to configure it because it was something that we had to to add to just the SatNOGS configuration that was on the station. And yet we had to add also a modem, so it could be some modem or DeWolf, to complete, I would say, the demodulate and the decoder solution for A-CubeSAT. However, we're still struggling at the moment to demodulate this data. And as you can see, we have some observations, but still no data on it. So what is next? So for the A-CubeSAT case, we are trying to configure the modem and contact the team or maybe some successful station owners that can maybe help us. But in general, what we can add is we can still find a way to implement the specific decoders directly into SatNOGS. So what was presenting Freddy earlier, thank you. And also maybe create some tutorials for newcomers like us to implement these decoders on the station. And of course, share our problem and give feedback so everyone can have access to this. So thank you very much, Red.
Great, Luis. So for Luis, can you shout out your yes? I want to hear that.
Yes. Yes. Yes.
Yes. We'll help them.
Very
Yes,
good.
yes,
Good.
of course.
So nice. Thank you, Luis. So you'll be around. That's very good to have you here. And I hope you join the Matrix channel so we can keep in touch on the longer run. So I think coming next is Turker. So Montos is preparing your slide. I hope you're around. Do I see a name?
I am here. Hello.
Great, super cool. Did I pronounce your name correctly?
It's Türker.
Türker.
It's like English Ü. It's the same in Turkish.
Turkish. Yeah, you think I'm Danish? Yeah. Turkish. That's good. So Turkish, your presentation is coming up. Montos is preparing it, and you will have 4 minutes, like everybody. Where are you situated right now?
I am in Ankara, in the capital of Turkey, and I'm a member of AMSAT DR.
Great, great.
Okay.
And Montos, the presentation is already there. You can select it. You see things popping by. Just give me a second. Oh, okay. It was already there, but okay. It's uploading. So you have a big presentation, so it's really nice. So by the time you come next, I see you don't have no, you don't have slides, which is okay. Then we have Manchester CubeSat. We don't have slides for you either. I don't know if you could send them to info. Francisco Barros or Antonis or Gregory, send it to info at OSCW.space. And then we have, let me just check again, Sunride with Alec Dent. We don't have your presentation either. So you'll see soon or enough that Turkish tell me your name again. I have to rehearse. Okay. Yeah, right.
Perfect. Eleftherios, thank you.
You have presenter rights very soon. 70% the system is saying. It's good. I have a chatbot replying. 80% people get ready. We're going to have an amazing presentation.
I think you win the prize for the largest PDF.
For 4 minutes, larger PDF. That's good. You count the megabytes 4 minutes. It's good.
I rehearsed. I promise I will do it in time. I will do my best.
No, don't worry.
You have to subtract now the upload time. So 1 minute goes away.
No, he's kidding. He's kidding. All right, that's the joy of remote work. All right, converting. It's coming up. Processing. Thank you, Mantos. Okay, 1 of 15. We're starting again the percentage. This is was not happy. Mantos, maybe you can see it. The presentation I think was already there, but I'm not sure.
It actually was there twice already.
Yeah. We love your presentation, so we upload it many times. It's a big one.
But the server storage is getting low now.
Yeah, maybe you can start your first slide. It should be a title slide, so maybe you can start on this. It's going to be ready pretty soon. Not pretty soon. 2:15. Ready, Mantos?
If you want, I can share my screen in traditional way. If you want.
The thing is that Mantos is in the presenter mode, actually uploading your thing. So if you do that, then we have to make sure that you already have your presentation there. You can do it. 6, 10, Mantos, talk to me. Talk on the microphone. You can talk in the room. We know what's happening.
Well,
Okay.
maybe just try with the slide sharing then.
Yeah,
screen sharing.
We should have done that in the beginning then.
Well, we did. But
it
was
you
there.
got presented of me, and I'm not sure if it uploaded, but it's processing now, so I have no idea.
It's the antenna, right? It's there already. So it's after just
I'm doing it. Okay.
I was doing it.
Then you do it.
Yeah. Sorry. Select, confirm.
That builds up the excitement for the slide.
Yeah,
Yes.
right.
Wow.
It's over there. So okay. The screen is yours in 5, 4, 3, 2, 1.
Okay, hello everyone. I'm Türker from AMSAT-DR and METU. Today I will introduce our study on the optimization of the UHF turnstile antennas for CubeSAT platforms. A turnstile antenna consists of perpendicularly placed dipole antennas in phase quadrature. It's circularly polarized, and this is important for onboard antennas to minimize the effect of Faraday rotation and orientation alignment loss. It's possible to change the radiation pattern of turnstile antennas by the optimization of the orientation of its arms. Thanks to its compact mechanical structure, this antenna type is very suitable to be placed on board. This is the initial simulation setup for the turnstile antenna on top of a single A-CubeSAT chassis made by metal material without any rotation or tilt for the antenna arms. This is parallel and perpendicular to each other. Right-hand side, you see the phases of the antenna arms. There is 90 degrees of phase shift between the ports. Do you see the screen? I lost the screen.
I kind of don't see like a weird logo. Can you go to the next slide, maybe? The conversion was, yeah, I think it's the conversion problem.
That is the 7 megabytes.
Yeah, 7 megabytes. Yeah,
that was the video.
Anyway, it's a simulation result which is optimized towards upper pole. As you see, the antenna is radiating towards upper pole, and by changing the orientation of the antenna arms, we can change the radiation pattern towards downwards, or with another orientation set for rotation and tilt, we can make the antenna to radiate nearly isotropic, equal to every direction. And in here, you see the design of the feed circuit for the antenna. After the simulations, we continue to study to prototype the designed antenna. It's our first feed circuit design. At the left-hand side, it consists of a RF transformer and 2 hybrid couplers from mini circuits. Its aim is to divide the power to 4 equal signals, equal power signals, and 90 degrees phase shift between neighboring ports. And this is the fabrication result for the antenna, and you can see it in my hand. It's made by JLC PCB in China with FR4. And these are the simulation and measurement results. I will pass very quickly. As you can see, at the left-hand side simulation, right-hand side is measurement. They're very similar to each other, and the fabrication is very successful when we compare with the simulation results. You can check from the PDF later. And I'm not seeing it again, I think. Okay. And this is the measurement setup at anechoic chamber in university. We have put the feed circuit on top of a single unit generic CubeSAT, and place it in anechoic chamber of Middle East Technical University, then measure the radiation. The most important thing to remind you is don't always rely on the data sheets. We needed a tuning procedure for the antennas because they were not working in the desired frequency bands. And at the left hand side, you see the measurement and simulation results on top of each other. They are very similar to each other, and they are radiating in the desired direction. In this measurement setup, we used upper pole radiating setup, in which I show you in the first slide, first radiation setup. And also this is the axial ratio measurement. This is the measurement of circular polarization. It's very successful with around 1 decibels. And as a result, we prototyped the UHF turnstile antenna module, and we optimized the radiation with different requirements. We will continue with a dual band turnstile antenna, including a VHF, and we will optimize feed circuits more, and we will work on antenna arms. And at the end, we will do deployment mechanisms, and we will release the project outputs under the name of open source CubeSat antenna project later. Up to now, we are developing it privately. And at the end, I want to thank AMSAT TR members, especially Koray and Eralp, who helped me on fabrication, and also Professor Sencer Koç, who helped us on measurements. And I want to thank Minisocus and Virtual Electronic for free samples. Feel free to contact me. I'm always open for collaboration. Also the other authors. And I want to thank you for organization. Everything is nice. Thank you.
Well done, Tucker. Thanks a lot. Thanks a lot for your activity. Sorry for the presentation hiccup. Sure, you usually had videos, so please stay around. Very glad to help you having this kickstart on your open sourcing. It's always good to start open source right from the beginning. But first, before you go, do you get a big yes from everybody?
Yes.
Yes. Absolutely. Yes.
Yeah.
Cool.
Yeah. Very good. So keep in touch with the community.
Thank you.
See you soon. So next in line is Code in Space with Bassam Al-Faili. Bassam, are you around? Could you turn on your microphone? I know you don't have a presentation, so just put another slide. All right, cool. Where do you stand, Bassam?
So greeting from Kuwait. I'm joining everybody from Kuwait City, Kuwait.
Nice, nice. All right, so the screen is yours. Please tell us more about Code in Space.
Thank you very much. I'm very excited to let you know about a new opportunity which is called Code in Space. Code in Space initiative is the mission of Kuwait's first satellite, known as QMR Kuwait, CubeSAT. It is an educational initiative of orbital space. QMR Kuwait is one new amateur CubeSat expected to be launched in Q2 2021. It is intended to be an open access CubeSat for students from around the world. Code in Space objectives mainly to increase awareness among students about current opportunities and challenges in the satellite industry, to encourage solutions to current challenges faced by the satellite industry. Also to encourage and empower students to design and develop new concepts that could contribute to the advancement of satellite technology. Also to increase awareness about new space, or known as Space 2.0, and its potential impact on humanity. So what are the benefits to students? There are many benefits, including learn about satellite flight software and embedded systems, explore a topic of your interest and learn more about it in real life setting, learn about satellite technology and understand satellite communications. Also gain experience in system design processes and protocols in engineering projects, develop new solutions, whether they're products or services that utilizes satellite technology. Also develop leadership skills such as teamwork, decision-making, and project management. Also demonstrate capabilities to university admissions and future employers. Of course, there are many topics that could be under the umbrella of code space. Just to mention a few, it could be something related to satellite communications, satellite operating system, flight software, ground stations, ground operations, also scientific investigations based on the onboard sensors readings, such as temperature, magnetic field, acceleration, and light. And last but not least, also you can develop games or mobile apps using satellite signals or data. So how would this work? Basically, we're giving the opportunity to upload code that can access OBC, COM, and onboard sensors. So students can come up with concepts for solutions and then write a proposal with their code. Once the code is approved, it will be uploaded to QMR Kuwait, and then it will be executed by the OBC, and then transmit the results back to Earth. We are accepting proposals from January 2021, and for more details and directions on how to submit, please visit our website at www.orbitalspace.org. Thank you very much.
Thank you, Bassam, and very on time. Thanks a lot. Do not hesitate to share your link over there. How much of a yes do we get for Bassam and his initiative? Everybody, yes.
Yes.
Good. Do not hesitate to start open source from scratch. Bassam, invite the students to do that. That would be great. And we share knowledge with no frontiers. That would be awesome, and no legal problems. So cool. So thanks, Bassam. We catch you later, and I hope to see you tomorrow too. And next in line is the Manchester CubeSAT research group. We should have Francisco Barros, Antonis Biros, or Gregory Hutchins, one of you in the room, so we know who to give the hand to. If not, then it means we can pitch something else. If you're not there, I get some messages. Let me check. No news from them. So okay, we'll switch. We'll go with the next ones. Thanks for sharing your link, Bassam. So Sunride, the student venture to democratize access to space. Do we have Alec in the room? Alec, are you there? Alex, not Alec. Alec isn't there. All right, so I think we can call it the end of the lightning talks. Unless somebody wants to share an idea right now, we would be happy to give you 2 to 4 minutes. So I'll give you 30 seconds to think. Do I have something to share with everybody now? 41 people in the room, 1.2 million on the YouTube stream. That's what the latest numbers. If not, we call it a lightning talk session. And okay, all right. Good, so lightning talk is finished. We're going to, in 4 minutes, we're going to start the afternoon sessions, UTC afternoon and almost evening sessions, where we have discussions and tutorials. So the room 1 will be led by Eleftherios and room 2 by Fernando Martin. Please, guys, can we have a reminder of the link of room 2 and the chat so that everybody can just click and go. Juan, I have something to say. You're the first one, or you're the one on room 1, right?
No, nothing to say. I'm ready.
You're just ready, right? You're already drunk. It's perfect.
Not yet.
Not yet. I mean, drunk water. Okay, I have tea. And it's a transparent glass, so you see the back. Sir. All right, we'd like to have 1 or 2 minutes just to switch room. So this room is is with Juan Lu about how to contribute to open source. I think he has a lot to share, and he's been doing an amazing job with Polyastro and managing the community as well. And on room 2, we have another session which will be facilitated by, sorry, wrong page, by Fernando. And this is, the session is about, okay, 2 things: Python implementation of the CCSDS file delivery protocol, CFDP, and then standardization of CubeSAT PC104 connector. And I think all of that is Arthur behind, right? So room 2, you will see Arthur. All right, Aleph, I'll let you lead that, and see you later. See you later, guys.
Hi. Juan, let me give you presenter status.
Sorry, say that again?
It gives you presenter status. Hey, Patrick, good to see you.
Hey, how are you guys doing today?
Yeah, good. You have the snowball. The sound is amazing.
Oh, thank you very much. Yes, I love the snowball. It's awesome.
Ready to share your screen, Juan, huh?
Yes, it works.
So, just a reminder for people coming late or not yet prepared about Juan Luis' presentation. Well, you need just 3 stuff: internet connection, GitLab account, and the Replit account. I will share this information on a chat just for you to keep it, be up to date. I'm just copy pasted Juan Luis earlier post on Matrix, so yeah, I didn't do a lot of work again.
Hey, you might want to turn your audio, just your input down just a little bit. It's
Yeah. I think,
very loud.
Yeah, that might be me. I'm the noisy one usually.
I think it just sounds like it's cranked all the way up at the moment.
I am very loud person.
Oh, I think you went too far the other way.
Yeah.
Technology.
Come back another half.
Like that.
A little more. Keep going.
Oh, come on, guys. I will not do the talking. Juan Luis will do the talking.
I think it's good. Right in there is good.
Mm-hmm.
It's like as high as it can without kind of breaking up the sound.
So, wanna give people 5 minutes more, or you think it's gonna be tight?
As you prefer, I'm ready to start. So if people are ready.
So, people, are you ready?
I'm ready.
Ready. Okay, let's get started then. Well, hello everyone. My name is Juan Luis Cano. I'm also giving a talk tomorrow, a short one about some of the projects that we're doing. But today we're going to do a very quick tutorial on how to contribute to open source projects. And for that, we're going to focus on one particular version control system, which is called Git, which is probably the most widely used version control system out there these days. And besides, we're going to focus also on a platform that hosts Git repositories, which is called GitLab. There's another one, which is GitHub, which is arguably more popular, but LibreSpace Foundation projects happen to be on GitLab. So I thought it would be nice to already understand like the platform that the LSF is using in case you want to contribute to those projects. Polyastro, my personal project, is on GitHub on the other hand, but in any case, both platforms work in a very similar way. And so I don't want to do any theoretical introduction or anything like that. We are going to jump straight to coding and typing commands. So I will be reading the chat here on Big Blue Button. And I hope that you have your laptops ready. So I'm going to share my screen now. Give me a second. All right. So the workflow that we're going to follow is very similar to this one, where you have two separate repositories on the cloud or some online platform like GitLab, GitHub, or whatever. One of them is the upstream, what we call the upstream. So the repository that you want to contribute to. This image is based on Atom, the famous editor by GitHub. But in case you want to contribute to LSF projects or Polyastro or whatever, this would be your upstream. Then we're going to make a copy of this upstream repository to our own account in this particular platform, which is going to be called a fork. So a fork is going to be like a copy on the cloud of this upstream project that we're going to use to push changes and so forth, because no matter what relationship we have with the upstream projects, we will always have full permissions and full write access to our fork, right? And then these platforms, both GitLab and GitHub, have a mechanism called either pull request or merge request, which will allow us to contribute changes from our fork to the upstream repository. And then in the middle of this lies our local checkout or local clone, local working copy, whatever you want to call it, which will be the bridge between these two, because we will use it to fetch changes from the upstream repository and push those changes to our fork or origin repository. Okay, so keep in mind this triangular workflow all the time. We're going to be based on this a lot. And so what we're going to do is we're going to fork this little repository here that only contains a README and a text file. And that repository is this one that I'm copying both in the chat and in the matrix room. For the viewers on YouTube, you can check out my gitlab.com/polyastro/git tutorial OSCW 2020. And the first thing we're going to do is to fork this project. So if you hit this little button here on the top right, which is fork, then you will see a window like this with fewer organizations that gives you the option to make a fork to your personal account of this repository. So I'm going to do exactly that in my personal account, which is this one here. Forking is in progress. Please wait while the minions do their work. Okay, so the project was successfully forked. So as you can see now, I have an identical contents here, but this repository is on my personal account instead of this Polyastro organization that I want to contribute to. And it says right here that this was forked from Polyastro/Git tutorial, blah, 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 blah. Okay, so that was the first step. Now the second step will be to clone this repository If you happen to have a working Git installation on your local computer, you're of course welcome to use that for the tutorial. In my particular case, I'm going to assume that you don't have it installed. And so I'm going to use an online platform which is called Replit or repl.it. So this platform is quite interesting, and it gives you free of charge an interactive development environment that works for several different languages, and also a Linux terminal with Git and an ability to install packages and whatever you want. So it's quite cool to do projects like this. And what I'm going to do is I'm going to create a new bash project so I can start hacking straight away. So I'm going to hit this plus button on the top right. When it says here, select the language, blah, 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 I'm going to choose bash. This is not really that important, but as we want this to be language agnostic, I'm going to choose bash, and that's it. If this were on GitHub, I could directly import this from GitHub, as you can see on the right, but we're going to clone it manually instead. And now I'm going to call this Git tutorial OSCW 2020. Okay, you can choose whatever name you want. This is going to be in your account. I'm going to make this public and create the REPL. Okay, so you will see a window like this. I'm going to save some space here and increase the text size so you can see what I'm doing better. Okay, hope that is enough. And so what I have this dummy file here that I'm going to remove. So you can see here on the right that I have a, sorry, who am I? A bash terminal, right? And I'm sitting on this directory here. And the first thing, I'm going to remove this main.sh file that I don't care about. And now I have an empty directory. And so what I'm going to do is I'm going back to my fork of this repository, and I'm looking for this clone button here. And I'm going to use this URL to clone the project. At the moment, as I want to make this as inclusive as possible, I will use the HTTPS URL because like last time I used Git on Windows, for example, there were some issues with SSH and keys and so forth. Everything okay, Eleftherios? Oh, okay. And so I'm going to ignore the fact that you might already have an SSH key or an SSH agent or whatever. So I'm going to use the HTTPS URL here and use my normal username and password when I'm asked for it. And so now I'm back to this terminal here. I'm going to type git clone, right click, paste. And I'm going to tell this to clone the URL exactly here in the current directory I'm in. And so you will see that this juanlu.txt and the readme appeared here. In fact, this Replit has a nice, what you see is what you get editor for Markdown and other languages as well. Okay, so now we completed part of the triangular workflow, okay, but we're missing the last leg, if you remember, which is linking our local repository to the upstream. Okay, so we need to add this link now. And for that, there's another command that's called git remote. If you just run this thing, you will see that you have one remote, which is called origin by default, which corresponds to our fork. So I'm going to git remote add upstream. Upstream is the name that I'm giving to the remote. And I'm going to use, and I'm going to use the URL of the upstream repository, so the one that was in the Polyastro organization. And again, I'm going to use the HTTPS URL here. So I changed the window, came to the Polyastro repository, and copied the HTTPS URL. I paste this here, And I'm good to go. Okay, if, like me, you observe this kind of shitty overlap with the terminal lines and so forth, I looked for a solution, and what worked for me was typing stty columns 200, or something like that. And in principle, I should not have any more troubles like this one. Okay, so now if I type git remote, I have two, origin and upstream. And now I have all my triangular workflow correctly set up. So I'm ready to start doing real stuff. How are we doing so far? Did you follow? Are you lost? What are your questions? Yeah, someone says copy pasting URLs into Replit doesn't work for me, but manually typing works. Yeah, manually typing it's not very convenient. You're right that Control-C, Control-V doesn't work, but what worked for me was right-click and paste. You are not seeing it because I'm only sharing one window, but if you right-click and copy and right-click and paste, it's going to work. Pradipta says on Windows you might need to do Control Insert. Okay. Boris asks, is the H in HTTPS missing? I don't think so, but maybe I did it wrong. I can check with git remote show upstream. Aha! You're right. I was missing a letter here. So let me do that. Let me do that again. I'm going to go back here. Oh my God, this thing about the lines is so annoying. I'm going to copy it again, and if I do git remote, in this case, as I need to modify this, I need to do set URL upstream, and now I can right-click, paste, and that's it. And now if I git remote show upstream, now it works. Thank you, Boris. Good catch. More questions? Okay, we're good to go. And so the next step will be a little bit of an introduction to Git commands and the statuses that we're going to use. So if you allow me for a second to visually represent what we're going to do. Okay, this image is the one that I was looking for. Where am I? Okay, so this image represents the workflow that our files are going to follow. And when we add a new file to the repository, it starts in the untracked state. So it's something that Git knows that is there, but it's not tracking at all. Then there's something called the stage area, which is kind of a preliminary step before actually committing the files. We will see what this means in a moment. So the stage area, you can think of it as some sort of preparation area or something like that. So the operation that moves an untracked or a modified file to the stage area is going to be git add. We will do a practical example. And then when we have several changes that are staged, we will do a step that's called git commit. And this is going to create a new snapshot on the history of the project. And the interesting thing about Git, for those of you that don't know, is that you can traverse to the past all these states and all these snapshots, and we can see who changed what, at what time, what lines did they change, and so forth. So this is a super powerful tool for everything that's related to plain text files, code files, and whatever, even configuration files, and so forth. And so we will move between these states all the time. So from unmodified to modified, then staged, then we will commit, and then that will turn the files to unmodified again, and so forth. And then at some point, when we're happy with our changes, we're going to make a push to our fork and then create a pull request. So that's how everything is going to work. And so we're going to start with some easy task here. I'm going to create a new text file here with my name. Mine in this case already exists, but I'm going to create a Juanlu2 txt file, and I encourage you to do the same, because then I will ask you at the end of the tutorial to make a pull request so I can include all the files that you created. Okay? So I can either use the Linux terminal here. If I do touch juanlu2.txt, it's going to create a new file here. Or you could as well as use the Replit graphical interface and click this add file button here. It's the same. And so if I open this Juanlu2, and for you, please use your own name, like Boris.txt, Pradipta.txt, whatever. So this is going to be, I'm going to write a silly sentence here. Hello, Earthlings, because hello world is just too popular these days. And so after I create this file, if I run now on the right git status, it's going to tell me a lot of information. This git status command is essential, and we will need to use this all the time. So it's telling me several things. First, that I'm on branch master. There are several branches that we can use. At the moment, we only have master, but we could create more. We will do that later, if time permits. The second line says, your branch is up to date with origin master. This means that my current master branch is tracking my fork, which is called origin, and in particular, it's tracking the master branch of my fork. That's why it says your branch is up to date with origin/master. So origin/master is a remote branch. And then it says there are untracked files, this juanlu2.txt, and it's encouraged me to do git add and the path of the file to include in what will be committed. In other words, to move this untracked file to the stage area. Okay, so for that, I'm going to do git add juanlu2.txt. As it's customary with the Linux philosophy, no news means good news. So if git add didn't say anything, then everything went okay. This is not always respected in Git commands, but it's very often done. So now if I repeat git status, the information changed a little bit. So we're still on branch master. We're still up to date with origin master, but now there are some changes to be committed. Okay, so there are two ways I can move now. I can either remove these changes from the stage area, that would be like returning to the previous step. So it would go from green to red. Or I can say, no, these changes are good enough for me, so I'm going to make a new commit. Okay, so we're going to do the latter. We're going to create a new commit, so a new snapshot. And for that, we use the git commit -m. Then we need to open quotes and then write a commit message. This commit message is something that is going to appear attached to every snapshot that you have on the repository. Therefore, it has to be informative to some extent. So use things like remove deprecated functionality or add new parameter to function f, something like that, and avoid silly commit messages like A, and stuff like that. Also because this is going to be in the repository for posterity. So don't put anything that will embarrass you in the future. And so I'm going to use here add file with my name. You can put any message that works. Okay. quite probably this is going to fail right now because I don't have my name and email configured here. Exactly. So no worries, but we will have to do this step before. And the interesting thing about these snapshots is that they're identified with my email and my name. Therefore, if I do now git config, I'm going to ignore this -- global part because I don't care that much about it being global or not. This is a testing environment. But if you're on your computer and it's the first time that you create a Git repository or a Git commit, then it's a good practice to do this -- global. I'm going to write user.email. I'm going to write my email. And git config, username, Juan Luis Cano Rodriguez. I'm not very happy with how Replit treats special characters, so I had to remove one extra I there, but at least it works. Okay, so now I have my email and my name properly configured on Git. So I'm going to repeat what I wanted to do before. Git commit -m, add file with my name. And now it works. It's telling me that one file changed. I inserted one new line. This file has mode 644, so normal write permissions without execution permissions and blah, blah, blah. And that the commit was created on the master branch and it's identified by a hash. And in this case is 89705, blah, blah, blah. Okay, so we created our first commit. And to make sure that we did it correctly, we will repeat git status. Now it will say we're on branch master. Our branch is ahead of origin master by one commit, and that we can use git push to publish our local commits. But other than that, there's nothing to commit, and the working tree is clean. How are we doing, folks? So far, so good? Am I going too slow, too fast?
You're doing fine.
Thanks. I see that Red has a status happy. That means that he's obviously happy. I'm going to make status to happy as well. Okay, so if there are no more questions, let's continue. I'm going to create another commit just to try a slightly different thing. In this case, I'm going to modify a file that already exists, this new file that I created. So I'm going back to the editor, and I'm going to add here, like, this is an extra line. Okay, so now if I repeat git status, it's going to tell me that we're still one commit ahead. We could do git push to publish our local commits. And now there are changes not stage put to commit. This is a very similar situation than before, with the difference that even though the color is the same and the message is almost the same, now we have some modifications on an existing file instead of an untracked file. But for the rest, it is exactly the same. And what I wanted to do is to teach you a little trick that not everybody knows about adding changes to the stage area, which is partial add. So if you do git add -p, this shows a very interesting window that it's going to go over each of the changes that we have pending on the repository. And then it asks us for confirmation whether we want to add this to the staging area or not. I use this tool all the time because I do a lot of changes, but I want to separate in a logical way all my commits. And so I like pick some files from this directory and create a new commit. I don't have an extra line at the end of the file, so Git is showing kind of a warning here. So what I also do sometimes is, like, on the fly, edit the changes that I'm adding to the stage area. This is going to add to fire a Vim editor. If you're not used to Vim or you've never used it, I highly recommend you to not hit an E here, but a yes. Okay, so if you're okay with Vim, you can do E, otherwise do Y. I'm going to edit this very quickly. Whoops. Oh, Vim is working really, really bad here in this. Oh my god. All the mistakes are live. So I'm going to try to quit here and abort the mission. Okay. Whew. Yeah, don't open Vim here. So let's go again. What's my status? Okay. So I added the changes. If I want to check, I can do git diff -- cached. And then it's showing exactly the diff that I'm going to add right now. And so with this, I'm ready to create, git status, to create a new commit, -m, add extra line. So git status now shows that I'm 2 commits ahead of origin master, and I can push my changes here. Okay, one extra trick that I want to share with you, which is something that I use a lot again, is a command to seal the past history in a nice way. If you do just git log, which is the base command, you will see something like this, which is still useful, right? It shows all the commits with all the commit messages and the full hash and name, email, the date, and so forth. But sometimes you want to see more of a more compact representation of the Git history. And for that, the command that I usually use is git log --graph, one line, decorate all. Again, I'm going to copy this command for you so you don't have to type it. And so the interesting thing is that I see, like I told you, like a more compact representation of the history. This is especially useful when you have several branches and so forth. Okay, and talking about branches, we're going to create one now, which is something that we haven't done so far. We have been making all our commits to master. But in the workflows that most projects use these days, what they encourage you to do is to create what they call short-lived branches. So you want to add some piece of functionality to the code, or to fix a specific bug, or to amend a typo in the documentation, whatever. And so they encourage you to create a branch for that change, make all the commits and all the changes that you need corresponding to that logical piece of changes that you want to do. And then when your contribution is merged to the upstream repository, then you can just go and remove the branch. Okay, so that's what we're going to do now. So I'm going to git branch first, just to make sure that we only have one branch. You see here in green the master branch, which means that we only have one. And I'm going to create a new one by using the command git checkout --branch. And then I'm going to give this a short name, like add Juan Luchu, something like that. No spaces. And so you can call these whatever you want. We're going to use this branch to make the merge request later on. So I'm going to, oh, sorry. It's not minus branch, it's -b. Git checkout -b at Juan2, and then it says switch it to a new branch at Juan2. Now if I do git status, it's telling me this information. And I'm going to repeat the log command so we can see where we're at the moment. Okay, so let's stop for a second and see what we are doing right now. We have our master branch, but we are not on our master branch at the moment. We are on my custom branch at Juanlu2. And you know that because there is a pointer in Git that's called head in uppercase. So this head is pointing now to add Juanlu2 and not to master. This means that the current branch that is loaded on disk in my environment is the add Juanlu2. These two branches at the moment happen to be at the same commit. So this means that they have the same information. And they are both two commits ahead of origin master and origin head, which are pointing at the same commit. All right, so what we're going to do now is we're going to push this branch to our fork, in which we have full write permissions. And then we're going to see what's the mechanism to open a pull request or a merge request in this case on GitLab. If you notice the output of git status here, you will see that it says on branch at Juanlu2. We already knew that because head is pointing to that. And it says nothing to commit, working tree clean, but it doesn't say anything now about origin. And if you remember before, when I was in master, it was saying like, you're up to date with origin master, or you're 2 commits ahead, origin master. And the thing is that as we created a new branch, this new branch is now not tracking any remote branch on my fork. So I have to create it. For that, I'm going to use the git push command. And the first time I do a git push, I will need to say which remote I'm using, in my case, origin, and what's going to be the name of the remote branch, which in this case is going to be add Juanlu2. Okay, so I'm going to run this command now, and it's going to ask for my name and password. A quick note about those of you that have two-factor authentication enabled. That's also my case. And if you have two-factor authentication and you used HTTPS to clone the repository, you will notice that your usual password doesn't work. Okay, to make it work, you will have to create a new personal token. And actually, that got recorded. So I'm going to revoke it right now. Give me a second. Stop sharing screen. Okay, I'll be back. Give me a moment. Okay. Sharing screen. Personal access tokens. Okay, and so if you happen to have two-factor authentication, then you have to go to your personal settings and create an access token like this, or use SSH, but for that you have to figure out SSH on Replit and so forth. So if you have 2FA enabled, I assume that you know what you're doing, so I don't need to explain this anymore. Now again, I'm going to stop sharing my screen for a second. I need to generate a new token that will expire tomorrow and will give me read and write permissions. So I copy this to my beautiful password manager. And I remove that from view, and here I'm back with you folks. Okay. +1 for the 2FA replica. Oh, thanks, Carol. So yeah, and now I'm here, and now that I have my token, I have AstroJuanlu as my username, and my password is going to be this one here. So I'm right-click, paste. That works, I promise. And as you see here, I pushed successfully. And so, well, this is telling me a lot of boilerplate about what Git was doing. I'm not interested about that. I'm interested about the last lines. So now the remote GitLab, in this case, it's telling us to create a merge request for @Juan, blah, 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 blah. You can visit this URL here. And we're not going to follow that, but it's a shortcut. It's a quick way of doing it. You could do it. Also, I anticipate that copy-pasting the URL might be a little bit of a mess, so I'm going to ignore it for a moment. Before going to GitLab, let's do git status once more. And you see that it's still not telling me what's the status of this with respect to the remote branch. So for that, I should have either done this, git push -u. Okay, so this -u sets the tracking branch automatically. So I'm going to repeat that for the crowds that are watching. And now if you add this -u, now it says branch @Juanlu2 set up to track remote branch, blah. And now I do git status. And now it's saying your branch is up to date with origin @Juanlu2. Okay, so now I'm automatically tracking this remote branch. All right? Okay, so now it's time to change the interface a little bit. I'm going to go to my fork. And if you refresh the page, you're going to see a little banner on top that says, you pushed to @Juanlu2 at your fork 1 minute ago. And it's showing a nice button that says create merge request. So this is the critical moment, folks, because we're going to create a merge request, and I'm going to notice how many of you are listening and how many of you are following the tutorial. So the number of merge requests that I get to this project is going to be a measurement of my success. Boris is typing. Okay, I'll let you ask your question at your own pace. So I'm going to hit the create merge request button here. And what you see is a form. This is a necessary step before actually creating the actual merge request, which allows you to configure a title. So you can say, like, there's an auto-generated title if you only have like one commit. So in this case, it says add Juanlu2. You can change it and say add new file juanlu2.txt, for example. And then you can say, I am enjoying your tutorial a lot. Here goes my name. Okay, and a lot of excitement in it. You like at the moment I'm displaying some extra information that probably you don't have, like the assignee and the labels and so forth. That's because my personal account has write permissions on the Polyastro organization. That might not be the case for you, but still you will have the title and the description and a button right here that says submit merge request. So I'm going to hit that button. And this is actually the second merge request, which means that there was someone that was this is from Joe 1 year ago. Okay. Sorry, Joe, I didn't merge this one in 1 year. Okay, so I don't see your merge requests coming. Is that because you found some problem, or because you're listening but you're not following? Oh, nice, Fabian. Thank you. Add file with my name and the LibreSpace manifesto. Yes. Excellent. And so I do have Fabian's change here. Okay. And okay, for the moment, nothing else. Okay, so let me open Fabian merge request now. Okay, so now you have to picture yourselves as the GitLab didn't recognize my user. Probably it gets detected by email. Oh, we'll get to that. I'm going to close some of this noise. Off topic. Okay, so now as the owner of the project, I do have this interface here that says that Fabian opened a pull request, merge request. In GitLab they're called merge request. In GitHub they're called pull request, but they're the same. And so there's optionally some description here that we don't have in this case. Here's the list of commits. So it says Fabian authored 19 minutes ago, add file with my name and the LibreSpace manifesto. And I have the list of changes here, right? So I see all the text and so forth. And what I can do, that's great. What I can do is to make comments, for example. So if I say, for example, this space is humanity's future, I notice that this apostrophe here is not the ASCII character for the apostrophe, but actually some sort of Unicode or UTF-8 translation of it. So I'm going to write a very, very picky comment here and say, hey, Fabian, thanks a lot. Could you please replace this little character here by ASCII apostrophe? And then, well, I'm going to ignore this reduce part, which is kind of new, by the way, and I'm going to add a comment straight away. And so now Fabian has probably a new email, or at least a new notification that says that I reviewed his pull request, merge request, and I gave a comment. So now he has the option like to say, no, I definitely don't want to change this character because I like the way it looks and it's better than the ASCII one. Or he can say, oh, good catch, I will go to make this. So whatever happens, it's going to be a conversation now between him and I. And point, and we're going to reach an agreement about whether the merge request is ready to be merged or not. In the meanwhile, I'm going to check if there are other people pushing. No, apparently not. And so for the moment, I'm going to assume that this was all done correctly and whatever. So I'm going to say, never mind. It's not that important. So I'm going to add a comment. Having said, good catch. So anyway, I'm going to resolve this thread as a maintainer. And this is ready to merge now. So I'm going to hit merge button. Or I'm going to approve. This is optional, but it might depend on the project. Some projects have like a policy on how many approvals does a merge request need to be merged, for example. And I'm going to merge it. Yay! So that was it. Merged. I'm going to congratulate my contributor as always, because we always have to celebrate contributors and we always have to celebrate open source and the joy it brings. So now we have a new contribution, and I haven't actually removed the branch, so we're good to go. And to simulate the next steps that we need, I'm going to also merge my own merge request here and say, oh, awesome sentence, you're so smart. And approval is optional. Going to merge and delete the source branch, and that's it. So now there's no more active merge request apart from this one from Joe from some time ago. So I'm going to go back to Git and do some cleanup that we need to do after that. The branch removal was done automatically, says Fabian. Yeah, absolutely. But there's a checkbox that you can tick. And I've noticed in my experience with open source projects that usually people get the first pull request right, but they get the second pull request wrong because they don't know how to do what we're going to do right now, which is acknowledging that some changes were made on the upstream repository and accommodating everything so we're back on a clean state again. And so for that, what we're going to do is to say, okay, so what's my Git status? Okay, so this is still up to date with Juan Luchu, blah, blah, blah. But now I'm going to do several steps. The first one, I'm going to go back to the master branch. So git checkout master. And you notice that this still says your branch is ahead of origin master by 2 commits. And we know this is false because my merge request was just merged. Therefore, what's going on here? Git doesn't have a magic wand to know when my merge request was merged. And therefore, I have to tell it to fetch these new changes and to acknowledge them. And the command to do that is git fetch. Git fetch origin. Oh, sorry. When I do git fetch without adding anything, it's using by default the remote that's tracking. Therefore, right now I did git fetch origin, but actually what I want to do is git fetch upstream. So now I have some information. Okay. And if I repeat git status now, it's still going to tell me that I'm ahead of origin master, but what I usually want to do is to make my master branch not track my fork, but the upstream repository. Okay, so for that, I'm going to do git branch -- set minus upstream 2 equals upstream master. So this command here now did the magic, because if I repeat git status, now it's telling me that my branch is behind upstream master by 3 commits. Okay, so now it knows that I'm lagging behind because there were 2 merge requests that were merged. And so I can move my status forward. So what I'm going to do, and before doing anything, word of advice, I highly disagree with the message that Git gives here, which says, use git pull to update your local branch. Again, in my experience, git pull has some weird effects sometimes because it does different things depending on the status of the repository. And so my advice is git pull -- rebase. Sorry. No, that was another thing. What I wanted to say is instead of git pull, to do git merge --ff only, which means fast forward only. The advantage of this approach is that you will not mess up your repository if for some reason your branches diverged. Okay, so if you have a linear history that can be fast forwarded, this is going to succeed. And if you have some weird stuff that you don't know what it is, then this is going to fail. And then you can decide what to do about it. But at least it's going to fail early. And when you're learning it, you want it to fail and tell you explicit error messages as much as possible, because it's not so easy to use sometimes. So I'm going to do git merge --ff only. And now, as you can see, it's saying that it created a new curl.txt file with a lot of lines. And if I repeat git status, now it says that I'm up to date with upstream master. Okay, so we're almost done. 2 last steps before we finish. One of them is to acknowledge the fact that there were some branches that were removed, both from our fork and from the remote. So for that, we have to do git fetch -p from prune origin and git fetch -p upstream. Okay, no news from the upstream one, but it says that my add Juan2 branch was removed. And the last thing, if I repeat the git log --graph, 1 line, decorate all command that I did before, you see now that we have more of an interesting structure. And I see that I have this local branch add Juan2 that was already merged, and therefore it doesn't make any sense to keep it around anymore. And what I'm going to do is to git branch -d add Juan2, and then it's going to say deleted branch add Juan2. So now I can repeat my git log, and it shows something like this. So now there are no extra branches. My master and the upstream brancher, sorry, my master and my upstream master are on sync. And the final step is to sync my origin master with the other two. Okay, because you see that origin master is still lagging behind. So now I will do git push origin master. It's asking me again for my username and password. And so I do that. And with this final step, if I repeat the git log, you will see that now both master, upstream master, and origin master, so all three are in sync. So this is the perfect situation to keep on hacking, because now I can start from a clean state and continue doing merge requests. All right, so make sure that every time you submit a merge request and it's merged, make sure to update these changes. All right. All right, so we got this contribution. Thank you, Fabian. I don't know if there were more people pushing. I see that we don't have more. So just a couple more comments for the usual way of working when you're working with a very big project. At sometimes it will happen to you that you have some branch where you're doing some stuff, and then maybe you cannot work on it for some time or whatever, and there are some upstream changes on master that you need to take into account. Okay, so I'm going to simulate that situation. So imagine that I git checkout And now I'm going to go a little bit faster just to show how it works. So imagine that I check out a new branch and that not theme, sorry. That I change the README here. Some changes to the README. Git status. It's going to tell me that there's that. So I'm going to add the README and I'm going to commit new changes to README. All right, so I'm going to push git status. I'm going to push -u origin new branch just to simulate that I want to open a merge request. Okay, and so I have a new branch. Okay, but now the creators of the project made some changes upstream. Okay, for example, I'm here in the Polyastro Git tutorial, so this is like the upstream official repository. And I'm going to add some changes here to Juan Luchu because and this is another extra line. Update Juan Luchu and committing directly to master. Notice that I can commit changes from the web interface. I don't need to use necessarily the commands now. And also I'm going to make a very nasty situation, which is a conflict. So I'm going to modify this line and say this line has to go first. All right. So these changes were made while we were working on our fork. Okay. And so what happens now? If I try to open the pull request, I'm going to go here to merge requests. Actually, I'm going to go to my fork. I will create a merge request, new changes to README, submit merge request. But now what happens? You see, I cannot merge it anymore. The merge button is not green because there are merge conflicts. And this is very likely to happen, especially in a big project. Like the moment two different people modify the same line of the same file, there is a Git conflict. And why? Because it's not obvious for Git what line should go first, right? So we have to fix that situation. And so for that, if I do git status, then what I'm going to do is I'm going to fetch the changes from upstream, right? And if I repeat the log that I had before, you see that my branch is lagging behind the current tip of upstream master, right? So I'm going to git rebase my branch on top of upstream master. But what happens that Git gives a very loud complaint about this conflict that I was anticipating already. So it's telling me essentially that it tried to fix the conflict, but it couldn't. So now it's all on my side to try to fix this conflict. So I'm going to edit this file. And you see on the first part, it was highlighted the changes that were in upstream master, and then my changes. So now I have to decide what's the final outcome of this conflict. So I'm going to keep this line first because it says this line has to go first. And then I'm going to put this line second. Notice that there's another way to fix the conflict, which is this one, right? So I can as well decide what to do. But I'm going to use this situation here. And so when I'm done, it says use git add to mark resolution. So git add readme.md. And now I can continue with the rebase. I can do git rebase continue. And now my status says that my branch and my remote branch have diverged. So I don't care what the changes in my fork were because I did a rebase. So now I'm going to fix this by doing git push -- force, typing my credentials again. And I'm done. So now when I refresh this pull request as a maintainer, I see that now I can merge this pull request, okay, because the conflicts have been solved. Right, so I'm going to do just that, and we're happy again because we have a linear history. And remember that after this, I would have to fetch the changes from upstream. So git checkout master, fetch from upstream, merge with fast forward only, git branch, and then delete my new branch and push to origin master. And if I repeat the git log, I forgot to remove the remote branch, right? Okay, so, because I had to do git fetch -p origin. And now I'm happy again because all my 3 master branches are in sync. I did a merge request, I fixed the conflict, and I got a second contribution to the project. So that's it. That was the tutorial. I hope that it was useful for you, that you learned a thing or two. And I'll be happy to answer any questions that you might have. Thank you very much.
That was really cool and helpful. Boy, I do many mistakes using Git because yeah.
Everybody does.
Yeah, I know I am not that comfy in coding. I have to admit that. I'm the least comfy person on the LibreSpace board, and yeah, that tutorial is really helpful. I will retake it. We can do commits to your repo even after the event, right?
Yes, of course, as much as you want.
YouTube, because I think it's useful and it's a really helpful tutorial for people that are afraid of Git, like me. Okay, I'm checking out if there are any questions. I don't see any on Matrix. Let me check out.
Thanks, Fabian, for following for that merge request.
No problem. Always happy to see how to teach Git, and would be nice if others would also be able to merge. But yeah, I guess it's also possible in the next days to
of course.
merge requests.
Yeah, it was really helpful. I have to admit that. I will check it again and again. I mean, I'm doing so many mistakes and never clean up my branches. And yeah, it's a mess. It's usually a mess. And okay, usually when I do stuff like that, I'm around at the local hackerspace because many LibreSpace persons are hanging around there. So usually they are just saying, you know, you have to type this and that to clean it up. It will be the mess again. That was really helpful.
Yeah, usually like, you know, Git has a very bad user interface in the sense that there's lots of jargon, right? Like a fork, branch, Git, checkout, commit, like you have to explain like a million words to properly understand that. But I think there's a point when you make click, like when you understand how the operations manipulate the graph of commits. And from that point, then you know exactly what you need to do. Like, okay, I need to rebase, or no, I'm behind this, so I need to fetch and I need to merge. So like it takes some time, but if you approach it like there's something you can learn, like these abstractions, and you can get super productive with it.
Totally. And if you start to be able to visualize the graph, not only on your computer but on your head, how the thing works, and understanding the processes, starts to have a flow.
Absolutely.
Great. Red one reminds us that that's a good question from Freddy. He asks if there are any suggested graphic tools for Git.
Well, I don't use any on my side. Like I usually use like this git log magic command that I pasted to you to do all my stuff. Although I find myself using, for example, the online capabilities of GitLab and GitHub that can also represent like the graph and so forth. And that's my graphical tool of choice. I think people were very happy with one called Git Kraken.
Yeah.
I don't remember if that's open source.
Yeah, I think it's...
No, it's not open source.
It's not, right?
Yeah. Boris Agret says that Git Ahead is a great graphical user interface.
Git Kraken has turned private. Too bad.
Yeah. Red says that his favorite graphical tool is the Terminal.
Oh, this Git Ahead one, I didn't know it. And it is open source, right?
I am not aware of it, to be honest.
Let me check. License MIT. Awesome. So thank you for that. I'm pasting
That sounds interesting. And it's in GitHub, Git Ahead. So yeah, worth checking out.
Red, my favorite graphical tool for Git is the Terminal. Yeah, I agree.
Tortoise, Git.org is suggested by Fabian, right?
Tortoise. This is for Windows, right?
Windows. Yeah.
Is this open source or?
It's open source, but I can't say anything more about it, except that it's for Windows.
Yes, it's GPL. Okay.
I actually
never used it in the last 2 years.
A Windows machine to run it.
This one is on GitLab. So
yeah, Red says that it works great on Windows, actually better than Windows.
Come on, don't make fun of Windows. It brought Linux to the desktop, you know?
Yeah.
The year of Linux in the desktop was 2020. What are we going to make of 2021? What I like with Git K is that I can see my commit history for file or directory. Oh, nice. That's nice.
Okay.
I don't know about you, but I always tried different graphical user interfaces, and then at some point I went back to the terminal. I don't know, maybe the effect is I want to know what's happening in the background, and I want to know what commands run behind. Not that I remember all of them, but it's just, I don't know.
You get the feel that you control stuff.
Yeah, man. I mean,
the false sensation that you control stuff.
Yeah.
Yeah, I didn't say so.
I take my email with mute, so don't take my my saying as an advice.
Can you share me now?
Sorry?
Yes, can I? Freddy?
Yeah, Fred is here. Yeah. Yeah, I just use also terminal, but sometimes when things are complicated with the graph with branches and tags, and I'm not sure, it's nice to have a graphical tool.
Oh, like what I do use a graphical interface for, though, is for fixing conflicts, because conflicts sometimes are a real mess, and I admit that I do not fix that on the terminal very often, only when they are trivial, you know. But even so, for example, my editor of choice in Python, PyCharm, has very good Git integration, and it has a magical tool to resolve conflicts. It has like a magic wand that
Really?
fixes the easy ones for you. Yes, like I'm in love with it. I sometimes open PyCharm only for that. And I've heard this is PyCharm Community Edition, right? So no need to pay. And then there's one open source tool that it's called Mailed that at least works on Linux. It's also nice to visualize like the 3 version of the files and fix the conflicts. And probably there are more.
Awesome. People have started drawing again.
Yay!
I love that you guys are so artful.
Elliptical orbits.
We'll have to
So,
take. I will
we are
have to take a
finished?
5 minutes. Yeah.
If we are finished, Boris and Rasika asked me to display a slide just for a moment, and I think that is their contact details. So I'll make you sad, and I'll remove the drawing board.
Yeah, go ahead.
The frame.
Drawing board will come back, people. Don't worry.
Go away. Stop doing this. Go.
It's, I think they're collaboratively drawing the future space station. All right, Boris. I hope you have it now.
So, this is the slide.
Super. Boris, a little comment?
Yes.
So I did have one question on the docs thing.
Go ahead.
On YouTube, but has it been compared to like some of the other stream like Orchid and SDK? Okay, so there I see it. It's third down.
Yes, I saw your question. Well, I would say the major difference with ORCID is a library, and you have to code the things. So what we did is to have an end user tool. You only have to prepare the configuration file. So only give the real data that the code cannot imagine by itself. ORCID, you have to code around the whole thing. So ORCID does contain a propagator. You've got some other like Celeste Lab that works with Scilab, which is also a library. But then you have to code your own code to make the propagation, to make and again, ORCID, as well as STK, as well as GMAT, as well as Scilab, they are focusing on trajectories analysis. So here with docs, what we intend to do is to cover the need of sizing the mission profile entirely. So it's not only about trajectories, it's about pointing, it's about energy, it's about data volume, it's about intervisibility with ground station, and so on. So that's what we intend to do with docs.
I hope that answers your question, Leonard. But I'll invite you to keep on discussing right after the wrap up. We will wrap up. Thank you, Boris.
And thank you, Mantos, for displaying this chart again. So that's because we like to advertise our remote service that will come soon, but that is not ready today. And then if you want to keep connected, we can inform you about the web page that will explain everything, but that is not ready yet. So please don't hesitate to mention that you are interested to receive updates at this address, and we'll add you to the mailing list.
Okay, great. So we contact you. You don't have the website yet, but we contact you and will be posted, right?
Yeah.
Cool.
Thank
Perfect.
you.
Thanks a lot.
Thank you.
Show that again. All right, Mantos, can you go back to the welcome slide? That'll be amazing. So thanks, everybody. This is closing day one. We will have some wrap-ups. So we have Arthur, Fernando, and I think LF also, where you could actually wrap up the talks of this morning. Maybe, Arthur, you want to start with the talks of this morning on room number 2. What
We'll
happened?
be back in 5.
Oh, all right, LF.
Yeah, this was quite exciting. The session where we covered a lot of aspects. So we were talking about onboard protocols, so how to communicate with your satellite. Then we also talked about the open source ecosystem and the relevance to even the space industry of it. We covered payloads, namely a telescope to take pictures of stars. And we talked about rockets. So basically all the ingredients you need to make a space mission. So just have a look at the session. It is recorded. You can recap it and then connect the points and build your space mission. Afterwards, we had in the afternoon, we had in room 2, I was presenting the CFTP protocol. So it's basically FTP for space application. So you will be able to upload and download files to your satellite. It's not as big.
Those series just after. Well, just for the, I feel like it was the morning.
Yeah, all right. That was the morning.
Yeah, just the morning for some people in the East Coast, maybe. And on room 1, so in parallel, a lot of things were happening too, and also not like the whole chain, but actually closing the gaps on different aspects. But first, we had the State of the Union with SatNOGS, where we Freddie put it well, that make us realize this happens collaboratively. So you also know how to collaborate. He gave some hints on how to do that. And this is a story of a million. So you have to build your own station. You have to be in the network. You build SatNOGS like that. Then we had docs, where we just had a reminder of the contacts right now with Boris and the team, with Rashika and Thibaut. This is closing the gap on mission analysis, somehow mission profiling. Sorry if I misuse the terms, but this is an important tool in the open source ecosystem for space missions. Then we have OpenSatCom. We had the debrief from LF on the report of this project and the development methodology for satellite communication. Of course, the satellite propulsion, so the miniature electric propulsion made by Michael Brady. We had some good insight on the progress and developments. This new fueled propeller that sounds like very promising, and we look forward to see it on a mission. Then also from Thessaloniki, Konstantinos provided like very detailed insight on the A-CubeSAT mission, which is a biological mission, so a bio lab in orbit in LEO, in a 3U CubeSat, if I'm correct, 3U. So and plenty of details, and the compactness you had to reach to leave room for the bio lab inside the CubeSat. And then that was the break, and we had lightning talks, plenty of lightning talks. Reminder for tomorrow: be ready for your lightning talks if you subscribe to it. If we have people dropping out, be ready yourself to provide your own ideas. There will always be like a gap somewhere where you can share your ideas. That's the point of meeting with us today. And but we had different things. I invite you to look at the timetable to have more details on everything over there. But interesting concepts on the turnstile antennas from Turek. I hope I pronounced your name right. The coding space from Bassam, the newcomer ground station challenges, and the power conditioning and distribution unit for energy in the CubeSat. So and then we had what just finished the hands-on and tutorial sessions. And Arthur, you started talking about your session with Fernando.
Yeah, so I was giving a tutorial on CFTP, the Python implementation that we did with CFTP, which is basically FTP for space application, sending files to your spacecraft and receiving them. It's surprisingly only now that it's a hot topic for space agencies. It's a not recent standard. It's relatively old, but it's just that it's being applied now, and it's going towards file-based operations. Yeah, I would be happy if you try this out. I gave a tutorial so you could live follow this and do some live hacking. And after that, we had a discussion on the PZ104 connector. The main goal is or the main outcome of this discussion was to make sure that we centralize our efforts on this, because the goal would be to have a central repository or a central point of information where we can find where we allocate what pins, what signals, and what data buses we are going to use. So in order to keep all our efforts, everyone is developing their own system or some supporting system, and that when you put this together, that this thing should not explode and it should work. And therefore we need standards, and we need to make sure that the systems are compatible.
Very nice. And maybe Aleph, you could summarize, or Juanlu, summarize your session, your impressions, and what did you share with everybody?
Well, can you hear me still?
Yeah, perfect.
So we were doing a Git tutorial, basically, but not only Git, but also how to use GitLab to make a merge request. So all the process from beginning to end, from forking a repository to cloning it locally and making some changes, understand how Git works and so forth. And that's it. I think it was quite informative by the comments. I also gave like a couple of personal tips that I use when working with Git every day and how to solve conflicts and so forth. So I'm looking forward for those new open source contributions going forward.
Very cool. Very cool. So this concludes the day today. The session remains open. We can still hang around, ask your questions around, share links, slides, or kudos, how you wish. This is how we make the new space. And if you have a question right now, you can ask. If it's directed to one of the presentation, you can mention. If it's a general question, you can also ask. And tomorrow we'll start again at the same time. Arthur, you want to say something? See you smiling. I see you want to say something.
Well, we are done for today, and but we go over now to the lounge for those that want. The lounge is open to anyone, so the whole public. You can find the link on the website, and in the lounge you can also create breakout rooms, so to have group discussions. But most importantly is grab some snack, grab something to drink. I mean, depending on the time, maybe in the US you're not drinking that early, but here's I'm going to get some red wine.
Of course.
All right. And meet you in the lounge.
9:12, nice.
Wow.
Yeah, I just had Ivan on the phone. It was more than 3 a.m. for him, so he went to bed. Australia.
Okay.
Am I going to be able to get on tomorrow?
Sorry?
Will I be able to get on tomorrow? I never got a emailed access.
Oh, okay. We can manage that. Yeah. Definitely. Looking at that right now.
Well,
Okay.
you managed it today, so
yeah.
Yeah, I think Arthur, you have something up for me, Arthur.
That would be the same access codes for tomorrow.
Yeah.
Yeah, I mean, I just did it through the LinkedIn. I think it was just opened up for anybody, and then I logged in during that time. So I never actually put in anything.
Oh,
Probably if you guys,
someone is cleaning up the slide. See.
No, we have to save first.
Okay, they're cleaning up. We have to leave the room. Yeah. See you in the lounge or tomorrow.
Lounge, yeah.
See you guys.
Yeah.
See you in 5, actually.
Bye, everybody.
Bye.
Hello. Good to have you.
People... Oh, the void. Who's the void?
Void. Making void.
Bye-bye.
We start with goodbye TLE, OMMs.
See you tomorrow.
And metasats.
Bye.
It's good. All right. We will close this.